Then welcome to my YouTube channel. So guys, I'm going to start end-to-end data science project implementation series. So in this series, actually, we'll be learning how we can implement end-to-end machine learning project, deep learning project, computer vision project, NLP project, generative AI project, and so on. That means we'll be exploring all the domain. What are the domain actually you have inside data science? We'll be learning each and everything. So guys, in this series, I will be starting with the basics implementation. Then I will go till the advanced implementation part. So in advanced implementation, actually, I will also use different kinds of MLOps tool for implementing these kinds of end-to-end projects. And this project would be, guys, completely industry ready. So we'll be writing modular coding here, and we'll be integrating lots of actually MLOps technology also, so that you can also directly mention this project in your resume. And apart from that, if you want to implement any other project with the same concept, you can also do it. So make sure, guys, you complete this series till the end. And after that, I believe you will be able to implement any kinds of data science related project. And guys, if you need this kinds of content more in future, you can support the channel, you can subscribe the channel, you can share this video with your friends and family, so that also they can get to know these kinds of content is going on in this channel. So please try to support the channel. If you are supporting the channel, so it will give me more motivation to create these kinds of content. And if you need anything else from my side, you can let me know. I'll also try to create that content as well. So guys, in this video, actually, we'll be implementing one basics machine learning project. See, as of now, I already know you already implemented so many projects in your Jupyter notebook, whether it can be machine learning, deep learning, NLP, CV, right? Any kinds of project you have implemented in your Jupyter notebook, or let's say collab notebook. But we don't know how we can convert this kinds of notebook project as an end-to-end pipeline, right? So this series will give you the entire idea how we can create the pipeline. Pipeline means we'll be creating the entire training pipeline as well as the prediction pipeline. Even we'll be also creating the user application so that user will get one web interface and they can give the data and they can get the prediction. Okay, so everything will be implementing in this series, so no need to worry. So here we'll be exploring different kinds of web framework like Flask, Streamlit, FastAPI. Okay, so different kinds of web framework will be also exploring in this project. Even after the implementation, we'll be also learning how we can deploy these kinds of projects in the cloud platform. That means we'll be exploring different cloud platform like AWS, Azure, GCP. So all kinds of cloud platform will be learning. And we'll be also learning how we can deploy this kinds of project as in CICD. Okay, that means if you want to deploy this project CICD, continuous integration and continuous delivery or deployment, how it can be also performed. So everything we'll be exploring in this particular series. So guys, as I already told you, here we'll be implementing one machine learning project. That means end-to-end machine learning project. So before starting this project, guys, first of all, let me show you what are the, let's say, component we'll be implementing through the entire implementation. That means the complete project actually overview. Then I'll be starting with the implementation. And again, I'm telling you guys, I'll be starting from the basics, then I will go till the advanced part. So this is our first actually implementation. So in this implementation, actually we'll be using one easy problem statement. Later on, I will also show you how we can also solve different kinds of complex problem statement as well. So guys, you can see this is the complete project agenda. Like what are the things we're gonna perform through the entire implementation. So the first thing I'll be discussing about the project introduction. Definitely you should know about the project introduction, like which particular problem statement you are gonna solve. Then I will also show you how we can create a GitHub repository. That means here we'll be also doing the version controlling, like we'll be committing our code in our GitHub so that we can perform the code management. So this will help you a lot whenever you will be working in the industry with a team. So as a developer, actually, you always need to update your code to the GitHub so that other developer can refer your code and they can also implement along with you. So that's why we'll be also learning how we can use this Git and GitHub properly in our implementation as well. Then we'll be creating the project template. Okay, because I always follow this step, guys. Whenever I implement any kinds of end-to-end implementation, I always try to create a project template. So this template gives me actually ability to organize my code. Let's say I want to do the code management and all. I want to, let's say, write an efficient actually end-to-end pipeline. So this template helps me a lot usually. So I'll show you my template. Actually, I usually prefer whenever I implement any kinds of project. If you have any other template idea, you can also create it. Okay, there is no issue with that. Then we'll be setting the projects as well as the requirements, because so whenever you implement any kinds of machine learning, deep learning, NLP, whatever project, actually, you usually use different kinds of framework. So here we'll be learning how we can set up these kinds of framework in our environment, how we can create the requirements file, how we can create the environment and all. Everything will be learning in this section. Then we'll be starting with the logging, utility, and exception module, because these three modules will help you to debug your code going forward, because we always need to write the login functionality in our code, as well as we also need to use the utility related functionality in our code, so this utility will give you the code reusability, let's say functionality, so that you can use the same function again and again, right? Then we'll be also using exception module, because see, whenever you are implementing any kinds of project, definitely there would be some exception, and how we can handle these kinds of exception we'll be also learning inside the exception module as well. Then we'll be learning the project workflows. That means here we'll be creating like different kinds of like folders and file. There would be lots of folders and file. Now for the first time, you need to know which folder actually you should change first, which folder you should change last. Okay, that's how, which file you should change first, which file you should change last. So these kinds of workflow you need to know. So we'll be discussing in the workflow section as well. Then we'll be implementing all the components in our Jupyter notebook first of all, because I know that you are already familiar with the Jupyter notebook implementation, right? So if I show you the notebook implementation at the very first time, so it would be more clear in your mind how we can use the same code for the pipeline implementation. That means for the modular coding implementation. Okay, that's why I kept this section. Will be first of all implementing all the components as about Jupyter notebook experiment, right? Let's say data ingestion, data validation, data transformation, model trainer, model evaluation. Okay, so this is called actually component. Okay, this is called actually entire training pipeline. So these are the separate component we have to implement. So we'll be implementing on the Jupyter notebook. Then we'll be trying to convert all the component as our modular coding implementation. Okay, I hope it is clear. Then with the help of all the component, we'll be creating the entire training pipeline. That means training pipeline means it's a step of execution. First of all, data ingestion will run, then data transformation will run, data validation will run, then transformation will run, then model trainer will run, then model evaluation will run. That's how it will execute entire pipeline. Okay, and that's how actually we'll be completing the training pipeline as well. Then we'll be also learning the prediction pipeline. That means whenever user will come, they want to predict something on top of the new data, that time prediction pipeline would be executed. And apart from that, we'll be also implementing user application. That means I already told you we'll be creating web application for this project, so that user can get one beautiful web application and they can get the prediction. Then at the last of the implementation, I will also show you how we can deploy this project as a CICD, okay, with the help of Docker in the cloud platform. So guys, this is the entire video agenda. So I hope now everything is clear. Now let's try to see the project introduction, which particular problem statement we're going to solve here. Then we'll be starting with our implementation. Now guys, you can ask me what would be the prerequisite to start with this implementation. So I'm expecting guys, you are already familiar with Python programming at least. See, inside Python programming, you should familiar with something called object-oriented programming. Okay, that means OP. Because here we'll be using OP concept for implementing the entire project. We'll be creating the class and methods, right? So for this OP is required. Then I'm expecting you are familiar with basics of machine learning concept, at least regression part inside machine learning, because the problem will be solving. This is a regression problem statement. Then you should have one AWS account, because if you want to deploy this project, so here I'm going to deploy this project in the AWS cloud. In future, I will also show you how we can use Azure cloud, GCP cloud. Okay, all the cloud will be exporting, but the first cloud will be using AWS cloud. If you don't have the account, so try to create one account. Initially, it will give you $300 credit, and this is enough for you. Then the last thing, guys, I'm expecting your dedication. So if you don't have the dedication, so definitely you will face difficulty. So put your dedication on whatever things I'll be implementing. So just try to implement along with me, so that each and every concept would be clear in your mind. And if you have any doubt, feel free to ask me in the comment. I will try to solve that particular doubt. So guys, the problem statement we'll be solving in this video. Actually, the problem statement name is wine quality prediction. So I think guys, you already have familiar with this data set, right? Wine quality prediction dataset. So this dataset is already available inside Kaggle website. If you just search wine quality dataset Kaggle, you will get this dataset. I think in Kaggle, you will see lots of competition is also going on with this dataset, wine quality dataset, right? So we'll be using this dataset because I already told you, first of all, we'll be starting with the very basics problem statement. Then we'll be starting with the advanced one, because I know that there will be so many learners, they are starting new this kinds of project implementation, right? But some of the, let's say, people are they're quite advanced in this field. So I have to take care for all of them, right? That is why I'm starting with the basics implementation, so that those who are starting with these kinds of concept newly, they can also cope up with the concept, right? In future, I will also implement advanced kinds of implementation, so that so that everyone can understand these kinds of concept. So guys, here is the data overview. So in this data, actually, we are having some features like fixed acidity, volatile acidity, then citric acid, then residual sugar. Okay, so these are the actually features we are having. Based on that, what we have to do, we have to predict the quality of the wine. So this is the simple problem statement, and this is a regression problem statement, because you can see the quality is a continuous number, and whenever we are predicting any continuous number, it's a regression problem statement. But whenever you are predicting any category, that means it's a classification problem statement, right? So here we'll be using one regression machine learning model. Okay, so with the help of this regression model, we'll try to implement the entire project. So guys, the first thing what I'm going to do, I'm going to create a GitHub repository for this project. So let's open up our GitHub and try to create one GitHub repository. So guys, if you're not familiar with Python, and if you want to learn the Python, if you want to learn about modular coding and all, so I think you already know, in my YouTube channel, I already created one playlist, the complete Python programming course. So here I have covered each and everything you need to know to master the Python. So here I have already covered the modular coding concept. So if you're not sure about the modular coding, so please try to check this playlist. And if you're also interested in generative AI, if you want to learn generative AI, I also created generative AI playlist as well. Apart from that, guys, you can also subscribe my another channel. So this is my another channel. So here also I created lots of content related computer vision, NLP, end-to-end implementation, okay, generative AI. So both channel actually you can subscribe, so that if I'm uploading anything, you can get the notification. So now if I want to get the GitHub, so just try to open up the GitHub, guys. So make sure you have the GitHub account. So if you don't have the GitHub account, so please try to sign up with the GitHub, then just try to create one GitHub account. Then the first thing, just try to click on the repository. So this is my GitHub, guys. You can also follow me here. So if I'm creating any repository, we will also get the notification. Now here, the first thing what you have to do, just click on the new, and here you can give the repository name. So let's say I'll give end-to-end. Okay. End-to-end, let's say wine quality. End-to-end wine quality. You can give any name. It's up to you. Let's keep it as public because I want to also share with you. You can also keep it as private. Then add the README file. Then add the git ignore. Let's say I'll take the Python. Then you can also take the license. Let's say I'll take MIT license. You can take any license. It's up to you. Okay. Now simply just create the repository. After creating repository, you also need to clone this repository. For this, just click on the code and copy this link address, HTTP link address, and make sure you have the Git client. For this, you can search Git SCM. So go to the website, and this is the Git client. Just try to download. So it will give you one Git bash. Okay. Now once you install, you will get this kinds of Git bash. Okay. So Git bash client, you can also integrate with your terminal. Okay. Terminal also you can also integrate. I already integrated with my terminal. So from my terminal itself, I can access my Git bash. So now let's open up my local folder, and there let's try to clone this repository. So here you just need to write one command called git clone. So with the help of git clone, we'll be cloning this repository. Now paste the link, just right click. So it will paste the link here. Now just try to press enter. See, it is cloning the repository here. After that, I will go inside the folder. For this, you can execute this command called cd. That means change directory. I want to go inside this folder, end-to-end wine quality prediction. Now, if I hit enter, you'll see that I'm inside this folder right now. Okay. Inside that, I'm going to open up my Visual Code Studio. So let's open up my Visual Code Studio. Now, the first thing, guys, we just need to create our project template, right? Project template means the project folder structure. Now you can create this project folder structure in two ways. Either you can create manually. So you can see inside VS Code, we're having some button already. Let's say with the help of this button, I can create any kinds of file. Let's say test.py, right? And this button, we can create any kinds of folder. Let's say I'll create folder. Okay. So that's actually you can create folders and file inside Visual Code Studio. Now let's say inside this folder, I want to create another file. What I will do, I'll just write, let's say t.txt or anything you can give. It's up to you. Then let's say inside this folder, I want to create another folder. Let's say test folder. Okay. So that's actually you can create multiple folder, multiple files. Okay. Inside that it is possible. But whenever actually I'm talking about end-to-end project. So let me show you some end-to-end project, actually real world end-to-end project. So if you go to Google and search for any kinds of end-to-end project, real world end-to-end projects, let me tell you about, let's say scikit-learn. Okay, scikit-learn GitHub. So if I show you the scikit-learn GitHub implementation, see, this is the scikit-learn GitHub, guys. Okay, scikit-learn GitHub. I think you already know scikit-learn is a Python library for the data mining and machine learning algorithm. That means whatever machine learning related task you want to perform, you have to use scikit-learn for this. And this is a scikit-learn implementation. Okay, the entire end-to-end implementation. Now you can see it is having so many folders and file. So this is the root folder called scikit-learn. Inside that, it is having all the component you can see. Okay, let's say I will open this component ensemble. Inside ensemble, you are having all kinds of ensemble related functionality. Okay, now let's say if I open up anything, see, this is the code implementation. Okay, And even they are also using something called modular coding, that means OOP concept, okay, in their implementation. Now you can see it is having so many folders and files, So this is called actually project folder structure. So scikit-learn is following this particular folder structure for implementing their implementation, right? So here we'll be implementing our project folder structure as well, so that we can also organize our code, right? So guys, what I have done, I already researched with these kinds of implementation. Like I saw different, let's say, real world project implementation. Then I created one of my actually project folder structure I usually use, okay, in my implementation. If you have any other idea, you can also create it. No need to worry. So I'll show you my project folder structure, how I usually create. So let me first of all delete. These are the folders. Now see, if I want to create those folders and file manually, so it will take lots of time, yes or no, because I have to manually create, and there is a possibility you may actually do the mistake, right? So instead of creating manually, what we'll do, we'll just try to create programmatically. That means here we'll be creating one file called template. Okay, template.py. Inside template.py, I'll be writing one Python script, and this Python script will automatically create my project folder structure. So it's just a one-time effort. After implementing this template.py, you can use this template.py for implementing any kinds of project. Only you just need to change the project name and just need to execute. It will automatically create your project folder structure. Okay. So here, first of all, you need to import some library. So let's import operating system. Then I will also import pathlib. I'll tell you why pathlib is required. I need to import pathlib from pathlib import path. Okay, I need this path class exactly. Then I also need something called login, because I also want to perform the login operation, right? And what is login, what is exception, I already clarified inside my Python playlist, guys. So there you just check it out, because here I'm expecting you are already familiar with these are the concept. Okay, I'm not going to explain the fundamentals concept here, because this is a end-to-end implementation you are doing, so that I'm expecting you are already familiar with this kinds of concept, right? Okay. Now, how to create a logging string, I think you already know. So this is the logging string, guys. Let's say if I want to log some information, I need a logging string, right? So for this, I need to use this kinds of logging string. Okay, this is my login configuration. Go to the login documentation, you will see that people are using this kinds of login configuration. So it will save your ASCII time, that means the current timestamp, as well as the log message you want to also show, right? So this is what actually it will be doing. Now the next thing, I will mention my project name. What is your project name? So as of now, I have given it's a ML project. You can also give wine quality project. It's up to you. But here, I'll give you this code as a template, so that you can use this template for implementing any kinds of project. Okay, that's why I've given ML project. You can also change with your project name. Like I also showed you, scikit-learn implementation. You can see they are giving scikit-learn. Okay, inside scikit-learn, they're having all the functionality. Got it? So that's how actually you can select your project name. Then after that, I need to mention list of the folders and file I want to create here. See, I have created one Python list. So this is the Python list. Inside that, with the help of f string, I have mentioned the folder name as well as the file name. Now you can see I'm creating one src folder. Inside that, I'm creating this ML project. That means my project name. And inside that, I'm creating one constructor file. Why constructor file? Because this is going to be my local package right now. If I show you, if I open the sklearn, inside sklearn also you will see this constructor file. See, okay. That means this sklearn would be considered as your local package. That means from the sklearn itself, you can import any kinds of functionality. Let's say I want to import, anything. Let's say I will open this base.py. Let's say I want to import this clone actually function. What I will do, I'll just write from sklearn. Okay, I think you saw that. From sklearn dot base import clone. That's how we can do the import operation. And this is called actually modular concept. I already explained in my Python programming playlist. If you go to the last section, you will see that modular programming concept. So there I already clarified this concept, right? So this is called modularity. And whenever you are importing like that, right? That means this folder should be considered as my local package. That means my Python environment should know this is the folder. This is my local package right now, so that we can import anything from this package itself, right? So this is why actually we use this particular constructor file. Okay, constructor file. Because this constructor file will help me to identify this folder as my local package. And inside this folder, I'm having some of the component implementation. Okay, so that is why we are implementing this. So that's why we are creating this file constructor at the very first. Then we are creating the component folder. Inside component also we are creating the constructor, then utils, then common, config. I'll tell you each and everything why utils, config, pipeline, entity. Okay, everything is required. I'll tell you each and everything. As of now, just try to consider these are the folders and file I have to create. Okay, for my project folder structure. And apart from that, guys, I'm creating some more files. You can see like params, schema, main.py, app.py, requirement.txt, setup.py, research, okay, template, index.html, because here we'll be using Flask to create the web application. For this, I will be using this Flask framework, and Flask framework needs this template. That means HTML code to create the front-end application, right? So these are the folders and file as of now I need. So this is my folder, and inside that I'm having the file. This is my folder, inside that I'm having the file. And these are the individual file. Okay, so let's create, then it would be clear, okay, how it will create the project folder structure. So for this, I have written one simple Python script, guys. So this is not very complex. See, this is a simple Python script. So first of all, what we are doing, we are looping through this list. You can see we are looping through the list. Then we are getting the path one by one. Okay, then we are passing into the path class. Actually, why we are passing into the path class? Let me show you one demo. So see, here we are using Windows machine. Yes or no? We are using Windows machine, and Windows by default use backward slash. If I show you, if I click here, it uses something called backward slash. But let's say you want to execute this project in the Linux operating system, or let's say Mac OS. That time definitely we have to use forward slash, because those operating system use the forward slash, right? So that is why here I have mentioned the forward slash. But here we are running this project in our like Windows machine. So sometimes Windows machine will give me the error. This path is not identified. Okay. So to prevent this kinds of issue, I am giving this path into the path class. This path class will automatically handle this situation. That means it will automatically detect my operating system. Based on that, it will convert that part. Let me show you one example. So first of all, let me import. So from, first of all, I have to activate my Python. So this is my Python, guys. Now let's import the path. So from pathlib, okay, import path. Let's say I will create one path here. So path is equal to, let's say, test/test.py. Let's as of now just try to consider this is your path. Okay, this is your file path. Now I'll pass this path inside my path function. Now see what will happen. It will automatically detect it's a Windows machine. See, it's a Windows path. Got it? And if you pass it to the Linux, it will automatically detect the Linux machine, Mac OS machine, everything. Okay, so that's how we don't need to manually take care. These are the things. It will be taken care by my this function itself. Okay, this library itself. So that's how inside Python we are having so many library we can use for writing robust application, for implementing robust application. Okay, so as a programmer, guys, you always need to create your application robust so that it won't be failing in the production. Your code won't be breaking in the production. Okay, I hope it is clear now. Now after getting the full file path, what I'm doing, I'm just extracting the folder as well as the file. That means I'm extracting the folder name as well as the file. How? With the help of this os.path.split. Let me show you another demo how it will give you the folders and file separately. So I'll open up my terminal again. So let's import operating system OS. Then if I pass this path to my this function, let's say os.path.split. Okay, inside that I'm going to pass this path. Now see, it will give you two actually things. One is the folder and this is the file in a tuple format. You'll see that this is the folder and this is the file, and we are unpacking it. I think you know how to perform the tuple unpacking. And after unpacking, folder would be stored in the file directory and file would be stored in the file name. Okay, after that we are creating the folder, okay, with the help of os.make directories. And after that, and after creating the folder, we are also creating the file. Okay, we are opening the file, and this is the empty file. Okay, I want to create, I don't want to create anything. That's why I'm passing the pass operation. And before that, I'm checking two conditions. If this file is not exist and this file size is 0, that means if it is an empty file, then I will try to create it. Otherwise, I won't be creating. Let's say in this file, I'm having some code implementation, so I won't be replacing that file, right? So this file should be skipped. So that is why this condition is required. Then after that, I'm doing the login operation. You can see with the help of logging.info. Okay, so it will show you the log in the terminal. Then if this file is already exist, it will give you one exist message. Okay, that's it. So this is the simple implementation I have done in the template.py. Now let me execute and let me show you the magic, how it will create the project folder structure. So I'll open up my terminal. I'll exit my Python. Let me clear. So simply just write Python template.py. Now see if I execute this line, okay, just see the magic. Left hand side, I don't have any folders and file. Now if I execute, see the magic, guys. Automatically it has created my project folder structure. Amazing, right? So now let me verify whether it has created everything or not. You can see guys, SRC. So open the SRC. Inside that you can see ML project has created. That means my root folder. Inside that constructor has also created. So let me show you the constructor. C _8__dot py. Then component. Inside component again one constructor. Then config. So you can see the config inside that one constructor and configuration.py as well. And constant inside that I'm having one constructor. Okay. Then we have created entity. You can see the entity. Then pipeline. You can see the pipeline. Then utils. You can see the utils as well. Okay. Everything is created guys automatically. Okay. I don't need to create manually right now. Okay. Manually will take time. With a few seconds, I created my entire project folder structure. Apart from that config, inside that I'm having the YAML file, the research, I'm having the notebook file, and all the separate file has been also created. You can see template also created. Inside that I'm having the index.html as well. I will discuss each and every file, why it is required. Let's say why config YAML is required, why params YAML is required. I'll discuss each and everything. No need to worry. As of now, just consider this is my project folder structure. That's it. Okay. I hope it is clear. Now let's see in future you need to create some other files and folder. Then what you need to do, you just need to add inside this list. Let's say I want to create another file called test.py. So make sure it should be a string test.py I want to create. So what I will do, I'll just open up my terminal and I will execute this command again, python template.py. Now see, it will create this test.py automatically, right? That's how you can create thousands of files and folder in just one shot. Now let me delete it. It is not required. Now let's commit the changes in my GitHub. So you can commit from your Git bash as well. You can also commit from your VS Code. So let me show you the Git bash, how it can be done. So just write git add space dot, then git commit. Okay, -m. This is the commit message. So folder structure. Add it, then git push origin main. This is the main branch. Okay. Now if I hit enter, see this is updated in my GitHub. Let me show you. So if I open up my GitHub and if I refresh, guys, you can see my project folder structure has been updated. Okay. Now you can start this repo. You can also fork it. It's up to you. And make sure you start the repo, guys. So if you're studying, that means other people can also get to know this is one amazing repository, so that they can also refer if they want to learn something, right? Okay. Now we have successfully created our project folder structure. Now the next thing, guys, what we have to do, we have to do the project setup. I already told you, right? After template creation, we also need to do the project setup. In the project setup, first of all, we have to create a virtual environment. Then we'll be creating, then we'll be actually installing some of the required package, okay, for this project. Then we'll be starting with our implementation part. Okay, so let me mention the command actually you need to execute for creating the environment. So guys, these are the command you can execute if you want to create environment, if you want to install the requirements. So the first thing what you have to do if you're using my repository, first of all, clone my repository. So let me copy my repository URL and let me mention it here. Then you have to create one virtual environment. Okay, so this is the command conda create -m. This is the environment name, and here you can use Python version. So here you can use Python 3.8. Either you can also use Python 3.10. It's up to you. Let's create with the help of Python 3.8. I'll copy the command and I will open up my terminal. Clear. Now let's execute. So it will create one virtual environment here. In the virtual environment, I'll be setting all the packages. And this is recommended if you're implementing any project, try to create a virtual environment instead of installing everything in your base environment. Okay. So guys, you can see my environment is created. Now I have to activate with the help of this command. So I already written the command, just try to copy and let me execute it here. So it will activate my environment. Sorry, I think I haven't copied. Copy. Now guys, you can see successfully it has activated my ML project, okay, environment. Now inside that I have to install all the requirements. So let me open the requirement.txt. Inside that, let me mention all the requirement package you need. So guys, these are the requirement I need for implementing this project, like pandas, notebook, numpy, scikit-learn, matplotlib, okay, python box, tqdm, pyml, ensure, joblib, okay, then Flask. Flask is for the web development, right? Web application development. And I will also tell you what is ensure and Python box. So these I think two packages are new to you. I'll explain, okay, what is it. And apart from that, I think you are already familiar with these are the packages, okay, why we use it with them and all, right? So first of all, let me install all of the requirements, then I'll tell you why we are using these are the package whenever we'll do the implementation. Apart from that, I also need to install this src as my local package, because if I show you my environment right now, if I just write pip list, you'll see that src is not mentioned. See, src is not mentioned inside my environment. Okay, that means if I want to import something inside the src folder, from the src folder, definitely I have to first of all install this src. Okay, src as my local package, right? So for this, I have to set up the setup.py. Inside setup.py, you have to write this simple code, guys. Let me show you. So this is the simple code, and this will help you to set up this folder as your local package. So here we are using setup tool. You can also mention the project version, then repo name, username, okay, author email you can mention, and this is the setup tool.setup. It will automatically set up this folder as your local package. That means it will look for this constructor file. Wherever this constructor file is present, this would be considered as my local package path, okay, local package directory. So again, you can use the same code in your other implementation as well. There is nothing changed, only you just change the repo name or username or email address if you're using any other email address. Okay, this is the idea. Now let me save. Now what I will do, guys, I will add one command inside requirement file. I'll add -e space dot. So this -e space dot command will automatically look for the setup.py and it will install the setup.py. Okay, now let me open up my terminal and I will copy the command pip install -r requirement.txt. So it will install all the requirement here. Let me show you. See, one by one, all the requirement would be installed. So this process will take some time, guys. Once the installation is complete, I'll come back. So guys, as you can see, my installation is completed. There is no error. That means congratulations, you have installed successfully. Now, next thing, guys, what I will do, we'll just try to create our three main component, like the logger, then this utility, and as well as the exception. Okay. So we'll be learning how we can write the logger, our custom logger. And see, exception I'm not going to write separately here because I'm going to use one library. I think, remember, this is the library called Python box. So inside Python box, we already have exception functionality. So you'll be using this exception functionality. You can also separately create the exception, custom exception. It's also fine. But I will tell you how we can use any other Python package as well to create the Python, let's say, exception. Okay, it is also possible. So let's create the logger first of all. Then after creating the login, we'll be creating the utility. Okay, inside utility, we'll be also writing the exception related code as well. So guys, to write our login functionality, so I'll open up this src folder. Inside that, I'm having one folder called ML project. Just try to open it up. See, either you can like separately create one logger folder. Inside that, you can write that login. Either what you can do, you can use this constructor file to write the login. Okay, so whenever I'm using this constructor file, so it would be easy for me to import that log. So I don't need to write actually too many import operation there. Let's say from src .ml project .logger import logger. Not like that. I can directly import like that. Let's say from ML project import logger. Okay, so these kinds of thing actually we can do. So for this, we'll be using this constructor file. Inside that, we'll be writing our log. So let's open up this constructor file. And I already prepared one custom log. Guys, let me tell you how you can write your custom log. So guys, as you can see, this is my custom log, and this log, how we can create, I already discussed in my Python implementation. So you can see, guys, this is the logging, custom logging we have created. So this is my logging string. So here we are saving the ASCII time, then label name, like log label name, then module, as well as the masses. Then it will create a folder called log. Inside that, it will create a file called running log. Inside that, it will save all the logging information. So you can see this is my login configuration. Inside that, I'm doing the file handler as well as the stream handler. So what is file handler? File handler means it will save everything in the file, and stream handler, it will also show you in the terminal as well. Okay, then this is my final logger object. Now let me show you how it will work. So let's import this login somewhere. So I'll import, let's say, in the main.py. So I'll just try to import like that. Let's say from ML project, because ML project has been installed as my local package right now. Let me show you. So if I show you the pip list, because I think you already know we installed setup.py, right? Now you can see this ML project. Now you can see, guys, this folder installed as my local package right now. You can see it is coming from local. That means whatever things I have inside ML project, I can import easily. There would be no error, right? So that's why we can import ML project like that. So from ML project, I want to import logger. because it is inside the constructor file. Okay, that's why we can directly import this logger. Okay, logger object. Now simply, if you want to log something, just write logger.info. Inside there, just try to mention your log. Let's say I will mention welcome to ML project. Okay, let me save. Now if I execute, see what will happen. It will create a log folder here. So Python main.py. Left hand side, you can see it has created one logs folder. Inside that, it has created one file called running log. Inside that, it has created one file called running_log.log. Now let me open it up. You can see, first of all, it will save the current timestamp and date. So when I executed this program, so this is the date and this is the time. This is the info level log. This is the file. That means from this file, actually, it is executing, and this is the log message. That means whatever, let's say, setup configuration you have given, ASCII time, label name, module name, message, everything will save here. I hope it is clear. Now, if I execute for the next time, let's say I'll give another message here. Welcome to channel. So see, it will also save another line. Okay, at the very first. Got it. Now I think you got it. How to write the custom log. Fine. Now also let's write the exception as well as the utility. As I already told you, exception I'm not going to write separately. We'll be using box exception. Okay. So for this, we'll be writing this exception in the utility itself, right? So let's open up my utility. Inside that, you are having one file called common.py. Let's me open it up. And now you can ask me, what is utility? Utility means, see, the same function you will be using again and again in your implementation. Let's say I want to read this YAML file. So I need to read this YAML file in each and every, let's say, component, data ingestion, data validation, model trainer, right? See, every time I don't need to write the same function again and again for reading this YAML file. So what I will do, I'll create only one function for the read YAML. I'll keep inside the utils, and whenever I need it, I will import from there. Okay, this is called actually code reusability. And these are the utility related function. Okay, these are the utility related function. This utility related function helps you to implement the projects without repeating that function again and again. Okay, I hope it is clear. Now I already prepared some of the utils function you need for this implementation. Let me show you. So guys, these are the utility related function you need. See, very simple. So let me select my environment. So click here. So this is my environment ML project. Okay. So now this error would be disappeared. Now guys, you can see I'm importing some necessary library. And here you can see I'm importing this exception from the box itself. That means the library we installed now, box, Python box. So here we are importing this box value error instead of writing our custom exception. Okay. Then YAML, then logger, then JSON, job lib, then ensure. I'll tell you why ensure is required. Then ConfigBox. Even I will also tell you what is ConfigBox. Then path. I think you already know what is path, because with the path we can solve the path issue. If I want to run this project in a different operating system, okay, then typing any. So these are the library I'm importing one by one, and see, these are the function I created. So read YAML. So this read YAML will take the YAML file path and it will return you the YAML content. Okay. Then I've created another function called create directory. Let's say you want to create a directory here. You can use this function. So going forward will be whenever we'll be creating the component. That means whenever we'll be doing the data ingestion, data validation, model trainer. So it will save the artifact, yes or no. It will ingest my data. It will save inside a folder. It will train the model. It will save inside a folder. For this, I have to create some of the folders and directory, right? So we'll be using this create directory that time. Then if you want to save anything in a JSON format, you can use this function. If you want to load anything in a JSON format, you can load this function. You can use this function. If you want to save any binary, you can use this function. If you want to load any binary, you can use this function. That's how I created some of the utility related function which you may require, okay, in your project implementation. So all the functionality I won't be using, but I kept just for your reference. If you want to use them later on, you can use it as it is. Then get size. Let's say you want to check any size of a file, you can use this function as well. Now guys, you can see with the help of box exception, I'm adding the exception layer as well. If any exception is going on, it will also throw the exception. Got it. Now let me tell you what is this config box and what is this ensure annotation. Okay, why we're using in each and every actually function. Okay, why it is required. So for this, what I will do guys, I will open up my resource. So you can see there is a resource trials.ipynb I have created. So inside these trials, we'll be doing the experiment. Like we'll be learning why we're using this at the functionality. Okay, these are the thing. Now let me first of all select the kernel. So Python environment, I'll be selecting my ML project. Okay, it's fine. Inside that, first of all, I'm going to create so inside this resource folder, I'm going to create a YAML file. So let's say I'll give it as test.yaml. And inside this YAML, I'm going to write some content. Let's say, first of all, I'll write the name. Let's say Buppy. Then I will also write the email. Let's say I'll add my email. Okay, now this YAML file I'm going to read from this notebook itself. For this, you can use this code snippet. So there is a package called YAML inside Python. We already installed YAML, I think you remember. So with the help of YAML, you can load this YAML. So this is my location of the YAML file, test.yaml, you can see. And I'm opening this YAML file. Then I'm loading with the help of safe load function, okay, inside YAML. Now, if I show you the data, whatever content it is returning. See, if I execute, see, whatever content I have inside the YAML file, it is returning. And if you see the type, of this data, it's a nothing but it's a dictionary. Okay, it's a dictionary. That means by default, if you're using any YAML file, if you're reading something, any content from the YAML file, it will give you dictionary, output, dictionary data type output, right? So now if I want to, let's say, extract the name, so what I have to do, guys, I think you know how to play with the dictionary, how to let's say access any element inside a dictionary. For this, we have to use the key name. So what I will do, I'll just write data. I'll give this square bracket. Inside that, I'll pass the key name. Let's say name. Name is my key, and it will give me bubp. Similar ways, you can also extract the email. Okay, email. It will give you email. Okay. So every time I just need to define the square bracket. Inside that, I have to give the key name. But can I call like that? Let's say if I just write data dot name. Can I call like that? If I execute, will it work? See, it won't be working. It will give me error. That means this object has no attribute name. But this actually syntax is more convenient than this syntax. I don't need to write square bracket. I don't need to write double quotation. I can directly specify the key name and I can get the value, right? But it's not happening here. So for this, we'll be using something called ConfigBox. Okay. So ConfigBox will give you this kinds of functionality so that you can get this kinds of output. Let me show you how it can be done. So first of all, let's import this ConfigBox from the box. So box import ConfigBox. So inside ConfigBox, okay, you have to pass the data object, whatever data object actually you got after reading the YAML file. Okay, so it will give you, let's say it will give you the data D. Okay, now see if I execute, now if I show you the D, now you can see it's a ConfigBox type right now. Now I can easily call the name. Okay, d.name, so it will give me name. And if I call d.email, it will give me the email. Okay, that means if you want to call like that, you can do it with the help of ConfigBox. ConfigBox will give you this kinds of ability. And this is like more convenient than this one. Okay, so this is a new package. That's why I thought let's also show you how we can use them in our implementation. With otherwise, if you're not using it, it's completely fine. But every time you need to call like that. Okay, that's why I thought let me show you this one as well, so that whenever we are reading any kinds of YAML file, so that we can let's say return all the, let's say, content as a ConfigBox type output, so that we can extract like that. Okay, I hope it is clear now. Now let me show you the next one, which is nothing but ensure annotation. Why ensure annotation is required? For this, let me show you another example. So ensure annotation. So let's say here I'm having a function. The function name is getProduct. So it takes two numbers, x and y. Both are integer type, and it will give you x times y. Okay, this is the product function we have created. Now if you pass any value inside that, so it will give you the product yes or no. Let's say x is equal to 2, y is equal to 4, it will give you 8. But if I pass like that, let's say x is equal to 2, y is equal to string of 4, will it work that time? Because here you have mentioned integer, but here you are trying to pass string. Now see if I execute, still it will work. Okay, still it will work. It is giving me 44 because it is multiplying this integer with the string, and that means it is repeating this string that number of time. That means 2 times. You can see 4. Okay. So let's say you have written a very big project and you are getting this kinds of unexpected output. That time you will go mad. Like, what is happening in my code? It is not giving me error, but you are getting unexpected output because of that. Because here you have already said it should be integer, but still you are able to give the string type input. Okay, it's not actually fair, right? So to overcome this issue, actually we can use one package called ensure annotation. So inside ensure, we're having the ensure annotation functionality. So let me import it. Then whatever function you have written, only you just need to add that decorator. Okay, so ensure annotator decorator on top of the function. Okay, now see what will happen. Now if I try to give the integer, it will work, but whenever you will try to give the string, it will throw you error. So it is throwing error. Argument y type class string function object does not match annotation type class int. That means here it is expecting integer type, but you are given the string type. Okay, that's how we can fix this kinds of small error, and we can make our code more robust. I hope it is clear now. Now I think you got it, guys, why we're using ensure annotation on top of all the function here. All right, great. So this is my entire actually login exception as well as the utility implementation. So guys, we are done with the login, utility, and exception. Now the next thing I'm going to show you the project workflows. Like here you can see we are having like so many files and folder. Now there would be a question in your mind, which folder I have to change first, which folder I need to change last. Okay, for this I always need to follow one workflow. Like here I'll be writing the workflow. That means step by step actually folder name, file name, so that you can refer that and you can update the code, right? So after showing you the workflow, what we'll do, we'll try to implement the entire project in our Jupyter notebook. That means this wine quality dataset will be getting and will be performing all the EDA, feature engineering, model training, okay, model evaluation, will be performing each and everything on our Jupyter notebook. Like whatever things you have learned so far, like Jupyter notebook implementation will be performing that. Then I will show you how we can convert the Jupyter notebook as our end-to-end pipeline. Okay, so that understanding would be more clear. I can also start directly coding the modular coding, but what will happen, you will get some difficulty to understand, right? Like how we are getting the pipeline, how this code is coming from here, right? So after implementing the Jupyter notebook implementation, it would be easy for you to get everything, because I'm going to copy the code in my from my Jupyter notebook in my modular coding. That is what actually we'll be doing, right? Okay, so let me first of all show you the project workflow. So guys, this is the project workflow. You can see, first of all, I have to update the config YAML file. Okay, the first thing you have to update the config YAML file, then you have to update the schema YAML file. You can see there is another file called schema.yaml. Then params.yaml. You can see params.yaml is also there. Then entity. You can see entity is there. I have to update this folder. Then configuration manager in src config. That means inside src config, configuration config, I'm having this configuration.py. I have to update this file. Then components. Then you can see component. Inside components will be having different components like data ingestion, validation, transformation. These are the component. Then pipeline. That means we have to update our pipeline. Then main.py. This is my endpoint, and then app.py. App.py should be my my web endpoint. Okay, web application endpoint. So if you execute app.py, it will launch on web application. Okay, so this is the entire project workflows. That means we'll be referring this workflow, then we'll be updating the code. Now it will be easy for you to update. Otherwise you will forget, right? But you have to update at the very first. Yes, so this is the workflow. Now let's try to implement the entire project as our notebook experiment. So for this, what I will do, guys, I'll create a notebook here inside research folder. I'll name it as experiment.ipynb. Okay, so inside that we'll be doing the experiment. So guys, if I want to perform the entire experiment, the first thing we need the data. Now you can ask me where I will get the data. So just go to the Kaggle website. So just search for red wine quality data set Kaggle. So Kaggle is already having that data. You can already download from. So you can download this data from the Kaggle website. So you can see this is the data, and here is the CSV file, guys. You can download this data. Okay, it's around 26 kilobyte around, and it is having all the features. The feature actually I showed you. So based on that, actually I have to predict the quality of the wine. Okay, this is the idea. Fine. So to just try to download the data, I already downloaded the data. Let me show you. So let me also give the dataset link in my notebook so that you can also download later on. So here I can mention data link. Okay, so if you click here, you will get the data. Now for me, I already downloaded the data. Let me just create a data folder here, and inside that I will move my data. So guys, as you can see, I already moved my data inside data folder, and this is the wine quality red CSV, and this is the entire data. Okay, now I have to load the data inside my this notebook. Okay, so for this, let's write the code. So first of all, I will import operating system library. I'll select my environment. Okay. Then if I show you my project working directory right now, so let's say pwd, you can see I'm inside research folder. But my data, it is present inside my project working directory. That means this root folder. This is my root folder, guys. Always try to remember whenever you are implementing any project, implement inside your root folder. Okay. So now currently I'm inside a research folder, but I have to come back inside this root folder. For this, what you can do, you can use this syntax. You can just write os.chdr. That means change directory where I want to go back one folder back. So for this, just keep .. Okay. Now if I see execute, now I'll be present inside my root folder. Okay, now see wine quality prediction folder. Got it. Now I can easily access my data. So first of all, let me import pandas, because with the help of pandas, we'll be loading the data. It's a CSV file, right? Now you can define the data path, data underscore path. So data is present inside data folder slash. So you can copy the name. You can mention it here, .csv. Okay, now let's load the data. So I'll just write wines is equal to pd dot read csv. I think you already know these kinds of basics of data analysis, how we can perform in. You have already learned in your machine learning, right? So here I'm not going to perform like so many EDA, so many feature engineering. I'll tell you whenever we'll be implementing advanced kinds of project, that time how it can be done. But here I'm showing you the implementation, how it can be done. One simple, let's say, problem statement, how we can implement in an end-to-end manner, how we can implement in an attractive manner, so that if anyone is seeing your, let's say, implementation, they will get impressed. Let's say if anyone seeing your work, they will get impressed for sure, because so far notebook experiment is there, notebook is there, right? It's not that much of attractive, but if you're trying to convert this notebook to the modular coding, okay, so definitely people will be impressed on your work, right? Because you have done the entire pipeline creation and all. And this concept you can use for implementing any kinds of project. This is my main intention here. I need to show you the end-to-end pipeline creation. For a problem statement, you can take anything. The things you have learned so far, you can use the same, like, let's say I'm in skill here. Whatever data analysis, whatever feature engineering you have learned, you can use the same concept, but only you just need to learn how we can convert them to the end-to-end representation, end-to-end pipeline. That is my intention here. Okay. Now inside that, let me pass my data path. Okay, so it will give you the data. So if I show you my wines.head, so this is my data, guys. You can see. So this is the quality of the wine, and these are my features. Okay. So these are my independent features, and this is my dependent features. Okay, because it's a supervised learning. Now, if you want to check the information of your data, you can use the info function. It will give you the entire information, the data type, okay, whether you are having a null value or not, everything it will give you. Even it will tell you how much memory it has used. If you want to get the statistical, let's say, analysis, you can use describe function. It will give you the entire statistical actually representation, like what is the count, mean, standard deviation, mean, okay, 20% quantile, 50% quantile, 75% quantile, as well as the max value. Okay, this is the entire data representation. So I think you already know, I don't need to explain. These are the EDA part. These are the simple EDA part we have already learned in your machine learning. Okay, I'm expecting these kinds of prerequisite. Now, if you want to check any missing value, I can use this one. So is null sum. So there is no missing value inside my data. It's completely fine. Now, if you want to plot them, so you can use matplotlib to plot the data. So you can see I'm plotting the histogram here. So this is the entire histogram. So you can see the data distribution. So most of the column are normally distributed, but some of the column you can see these are squid column. Okay. You can also perform different transformation to bring them to the normal distribution, but it's a basic problem statement. We don't need to do it. Okay. We can simply train the data. See here, my main intention is not to show you how to create a good model. Instead, how to create the entire end-to-end pipeline. Okay. Good model you can create. You can apply so many EDA, so many feature engineering. You can create a good model. You can get a good accuracy. Okay. For this, you can refer Kaggle notebook, how people are doing the EDA part, how they are doing the feature engineering part. Based on that, you can gain the higher accuracy. And the same analysis, the same, let's say, code you will be writing for the feature engineering EDA, the same code you can write in your pipeline as well. Okay. Now, simply let's do the 10-test split of our data. So I'll import the 10-test split from the sklearn. Then after that, then I will get the X data and Y data. You can see I'm getting, so you can see I'm dropping the quality because quality is my dependent. I don't need the quality inside my X, and here I need the quality. Now it will give you the X and Y. So this is the X data. And if you want to see the Y data, this is also your Y data. Now let's perform the 10-test split. So it will give me X10, X-test, Y10, Y-test. So here I'm performing 0.2. That means 20% data I'm keeping for the testing and 80% data I'm keeping for the training. So this is my final results. Okay, after doing the 10-test split. Got it? Okay. Now here I'm going to use one model called ElasticNet because it's a regression problem statement. You can use a linear regression. You can also use, let's say, decision trees regression, different regression algorithm you can use. But here I'm going to use ElasticNet because ElasticNet is a regularization algorithm. Here you will get regularization parameter as well. I think if you go to the ElasticNet documentation, so just search for Elastic sklearn. You can see it is having different parameter, alpha value, L1 ratio. Okay, then these are the parameter it is having. So you can tweak, these are the parameter, alpha value and L1 ratio, if you want to perform the let's say this regularization technique. Okay, so that's why you can see I'm using ElasticNet here, so that I can show you the parameter part as well, how we can play with different parameter. Instead of hard code them in my let's say pipeline, I can read from the YAML file. Okay, this is what I want to show you. So let me import ElasticNet. Now let's initialize my model. So you can see ElasticNet. Inside that I'm giving parameter alpha, L1 ratio and random state. Okay, these three parameter, alpha, L1 ratio, and there is another parameter called random state. Okay, this one. Got it? So then I'm feeding my data. You can see X10 and Y10. So it will train my model. Here I got my model. Now if you want to calculate the accuracy, so you can import, these are the metrics like mean squared error, mean absolute error, and R2 score. Okay, so let me import them. Then let's create a function. The function name is evaluation metrics. So it will give you RMSC, MAE, and R2. Okay, so it will take your actual value as well as the predicted value. So let me pass and let me get the matrices. So you can see I'm predicting on top of my test data, and this prediction result I'm passing to my evaluation metrics as well as the original one. So it will give me R2, MAE, and this RMSC. Okay, now if you want to visualize them, you can also print them here. Now see guys, this is my results actually I got. So R2 score I'm getting 25%. So you can also improve the let's say performance of the model by adding some feature engineering here, but I'm not adding because I'm telling you it's the basic implementation we are doing. Okay, going forward, whenever we'll be doing the like advanced implementation, that time I'll also add different kinds of feature engineering technique as well. So this is the entire notebook experiment of our project, guys. So I think so far you are clear. Okay, so far you are clear with the Jupyter notebook implementation. Now we'll be using the same concept, then we'll be creating the entire pipeline. Okay, this is my main idea. So now guys, the first thing we'll be doing the data ingestion. There are data ingestion component. That means we'll be ingesting the data from a URL. Okay, so this is what actually we'll be implementing. But before that, let me commit the changes, whatever, let's say new changes I have done. I also need to push to my GitHub. So now you can also push from the VS Code itself. So there is a button called source control. Just try to click here and make sure first of all you have to connect your GitHub with your VS Code. Okay, then you will be able to do it. So here you can give the commit message. So let's say I'll give notebook experiment done, commit, then push the changes. That's it. Now if I go to my GitHub and refresh, you'll see that all the code has been updated. Okay, all the command has been also updated. Fine. So now let's do the data ingestion experiment, like how we can ingest the data. First of all, again, we'll be learning in the Jupyter notebook, then we'll be converting everything as a modular coding. So guys, we have seen the entire notebook experiment. Now the first thing we'll be doing the data ingestion part. But before starting with our modular coding implementation, first of all, we'll be doing in the Jupyter notebook. Then once Jupyter notebook experiment is working fine, we'll try to convert this as our modular coding implementation. So for this, in the resource folder, I'm going to create another Jupyter notebook file. Let's name it as 01. You can also ignore this number. It's completely fine. But I want to show you the pipeline, like what will be the execution flow. That's why I've given the number. Data ingestion.ipynb. Okay, so let me select the kernel. So here, the same thing I have to do. I think you remember, we have to first of all get back to our root directory. Okay, that means our project directory. So for this, I have to execute these are the code. So let me copy paste here. Now if I again show you my project working directory, you can see I'm inside my project working folder. Okay, now if you see the workflow, the first thing what we have to update, guys, we have to update the config.yaml. Okay, so I think remember we created one config.yaml file here. So this is our configuration file. So see what you have to write inside config.yaml file. So you have to write some external variable. Let's say the variable you will be changing later on. Okay, so these are the variable you have to write inside config.yaml. Now let me show you. I already prepared some of the variable. So the first actually stage variable would be your data ingestion. Okay, so as you can see, we are performing data ingestion, and to perform this data ingestion, I need some variable. Like I want to create a folder called artifact, right? Inside artifact, what will happen? It will ingest my data. That means the source URL I have given, my data URL. So it will download the data from this URL and it will store inside the artifact folder, inside data ingestion folder. Now let's say next pipeline will execute, let's say data validation. Okay, so inside validation artifact, it will save all the validation related artifacts. That's how transformation, model trainer, model evaluation. So for each and every stage, I'm creating different kinds of artifact folder because I don't want to mess up with all the file, okay, in just one folder. That's why you have to create separate folder. It's a good practice actually. If you're not creating, it's completely fine. But what I usually follow, I create a different folder. Inside that I keep my artifact, right? This is the idea. Now for this, I have created one configuration file, config.yaml. Inside that I'm keeping all the variable name, all the path name, all the URL, okay, whatever I want to change later on. Let's say I want to change this URL later on. I want to change with any other URL here. So what I will do, I'll open the config.yaml file and I will change the URL here. So what will happen? It will reflect in my all of the code. Let's say whatever code I have written, all the pipeline, it will automatically reflect inside all of my code. I don't need to manually open up all the file and there I need to change, right? So that's why don't hard code. Okay, don't hard code anything. The variable you are using, first of all, try to decide whether it's a static or it's a dynamic. Okay, so based on that, you have to decide whether you have to hard code this variable or you have to keep this variable inside a configuration file so that you can change it later on. I hope it is clear now. Now these are the folders and files changeable. Later on I can change. That's why I have kept inside config.yaml. Okay, because as a developer, let's say if any other developer is coming and they want to, let's operate this project, what they will do, they will open the config.yaml file and there they will change. That is the idea only, right? And you can see this is the data URL. So what I have done, guys, this data I have uploaded in my GitHub. See, whenever I pasted this URL and I press enter, it will automatically download the data because this data is available inside my GitHub. Let me show you. So if I show you my GitHub repo, so this is one of my GitHub repos. So inside that you will see this wine quality data is present. See, wine quality data is present. Okay, you can also keep the data in Google Drive. From Google Drive also you can, let's say, read. You can also keep in the database. See, in this video I'm not going to use database because as I already told you, we are starting with the very basics implementation. Then we'll be going till advanced part. Okay, so this is our first implementation. So here I'll try to use simple technology. Okay, but going forward, I will also show you how we can use databases, S3 bucket. Okay, different kinds of storage service we'll be also using. So this data you can keep anywhere in your S3 bucket, in your database, anywhere you can keep, and from there you can read. So as of now, I'm reading from my GitHub because GitHub is a free. Okay, and you can even if you see the data size, it's also very less. So that's why you can store this data in the GitHub. And how to store the GitHub? Open up any repository, and there you just need to drag and drop the data. So let me show you. Let's say this is my data. What you have to do, just drag and drop the data. Okay, if you drag and drop the data, it will automatically get uploaded. Let me show you. See, it is uploading. Now once it is uploaded, just try to click on the commit. It will automatically commit the data. Now I'll cancel it because I already have it. Now what you have to do, you have to get the link. Let's say this is my data. I'll click here. Now you will get one button called view raw. Just try to right click and copy the link address. Okay, and this is the data link, guys. This is the data link, and this link actually you have to mention inside source URL. Okay, now this is my data ingestion folder inside artifact, and after downloading the data, it will save inside data ingestion folder as a data.z. And I also need to unzip the data, and it will save inside my data ingestion. Okay, so this kinds of path you have to define inside the config.yaml. I hope it is clear now. Now the next thing, I have to update my schema.yaml. So as of now, schema is not required because see, as of now, actually, I'm not creating the data validation. Schema I need whenever I will perform the data validation, like what is my data type, how many columns I'm having. So these are the information I will keep inside the schema. That means entire schema of my data. Okay, I think you know what is schema, right? Then I'll change in params.yaml. Okay, params.yaml you also need to change. Inside params.yaml, I will keeping all the model parameter. Okay, whatever model you are using, you can also keep the model parameter instead of hard coding those. Now see, as of now, don't leave this file empty. Otherwise, if you're executing the code, it will give you error. So as of now, just try to give some dummy value. I'll give, let's say, key value. Okay, like that. So it's a dummy value I'm giving. Also, I'll do it for my params.yaml as well. Okay. Now I think config.yaml updated. Now I have to update my entity. Now let's write the entity because see, as of now, we are doing the notebook experiment. That's why we are not going to change here. First of all, everything will be writing in our notebook. Then we'll try to copy paste in our modular coding, right? Now I have to create the entity. You can see I have to create my entity. Now what is entity? Entity is nothing but it's a return type of a function. Okay, now let me show you. I already created one entity. So this is the entity, guys. So it's a data class I have prepared. You can see it's a data class decorator. And what is frozen is equal to true, I'll tell you. See, here I have created one class called data ingestion config, and inside that, whatever variable you can see I have defined here, all the variable name I also initialized it here. Okay, and I have also mentioned the data type. Let's say if I show you root dir, what is this? It's a path type data, right? You can see it's a path type data. Then source URL, it's a string type data. Okay, then again it's a path, again it's a path, again it's a path. Okay, that's how you can also define the data type. Okay, now see this class, this is not actually Python like class, like the OP class. It's a data class right now. That means it can return these are the variable as a value. Okay, that means whenever, let's say I want to read this data root data directory, okay, what I need to do, I don't need to call the self, so I can directly initialize this let's say class, and I can read that variable. Okay, so this will so this is the convenience actually this data class will give you. And what is frozen is equal to true, that means whatever variable I have defined here, apart from that, if you want to define any other variable, you can't, because it's already frozen. Okay, so you have already given it fixed. Let's say apart from that, I don't want to keep anything inside that. Okay, I hope it is clear now. Now it will be clear whenever I'll be using this thing as a return type of a function, that time you will get it. Now as of now, let me execute. Now the next thing, you have to update the configuration manager in src config. So inside src config, you can see inside src folder we have config folder. Inside that we have configuration.py. So let's create the configuration.py, and configuration.py is nothing but it's a it will return actually all the configuration. Let's say root directory, source URL, local data file path, okay, zip file path, everything it will return one by one. But for this I have to import some of the library. So but before that, what I have to do, I have to first of all read all the YAML file, right? So for this, what I will do, I'll open the constant. Inside that I'm having one constructor file. Now inside constructor, I will return all of my YAML file path. You can see with the path library, I'm returning all the YAML file path one by one. Okay, so this is what actually I need inside my data ingestion. Now let me import all of them. And if you want to import, guys, how to import? So just write ML, just write from ML project. It is available inside, if you see, it is available inside constant, right? So dot constant import star. That means I want to import everything inside that file. Okay. Apart from that, I also need some utility related function as well, and it is available inside utility. I think you already know. Inside common folder, we created all the utility, right? Like read YAML, create directories. If I show you, so read YAML. This is one, read YAML and create directories. Okay, this is what actually I need, because I want to create a directory, I want to read a YAML file. Now let me import all of them. Okay, now I'll be creating my configuration manager. So this is the configuration manager class, guys, I have defined. You can see here I've created one class called configuration manager. Inside that I've created the constructor, and this inside the constructor I'm reading all the YAML file. You can see from the YAML file path, and from where it is coming from the constant. I think you already know. Then I'm creating the directory, which directory? Root directory. That means artifact root. That means one folder would be created named artifact. Now you can see I've created one method called get data ingestion config, and it is the, and this method return type is a data ingestion config. The data ingestion config we have defined. Okay, that means it can only return, these are the variable. You can see these are the variable it is only returning, and from where it is getting from the configuration, whatever things we have created inside the YAML file. Okay, now this will give you the entire configuration, that means entire data. Okay, so that is what actually we have to do, and this is called actually configuration manager. Okay, basically for a software you are creating some configuration which you need to create the pipeline. That is what actually we are doing. Now the next thing, I have to create the component. Okay, component, that means my stage like data ingestion, data validation and all. So first of all we have to create a data ingestion component. So for this, let me import some of the library. So these are the library I need. Now let me show you my data ingestion component. So guys, you can see this is my data ingestion component. I created one class called data ingestion. Inside that I'm reading the configuration, and this data ingestion takes actually data ingestion configuration. That means whatever, let's say, configuration you have created now here, this configuration. So it will take all the configuration. Based on that, actually it will perform the data ingestion operation. Now you can see I'm downloading the data first of all with this method. So with the help of request library, it will download data from the source URL. The source URL you have defined here. Okay. Then once data is downloaded, it will perform the login operation. Then it will extract the data. It will extract the zip file. Okay. So this is what actually we are doing, simply step by step. Now let me execute and let me show you. Okay. Now the next thing, I have to create the pipeline. So pipeline means the execution flow. Like which method you have to execute first, which method you have to execute last. Okay, so here is the pipeline, guys. First of all, I'm initializing the configuration manager, because inside configuration manager, I'm having data ingestion related configuration. Okay, so that is what I'm initializing. And then from this configuration manager, I'm getting the data ingestion config. That means this configuration, and this configuration I'm passing to my component. Okay, data ingestion, you can see this is the data ingestion at index this component, right? So that is what actually we are passing, you can see. Okay, then after that, I'm calling this method, first of all, download file and extract the zip file. That means this is the flow of execution. First of all, this function will run, then this function will run. Okay, and now let's say you are executing this extract zip file at the very first. It will give you error because data.zip file is not present, right? So first of all, you have to download the data, then you have to execute the extract zip file. Okay, this method, this is called pipeline. Now see, if I execute the pipeline, you'll see that it will create an artifact folder. Inside that, data ingestion folder, inside that it will ingest the data, and it will also unzip the data. Let me show you. See, it is executing. Now see, ingestion is done. Now if I show you the artifact, now guys, you can see inside artifact, data ingestion is created. Now data.zip file as well as my wine quality rate.csv. That means it has also performed the unzip operation. Now you can see my data ingestion pipeline is running successfully. There is no error. And this is what actually we have done inside our Jupyter notebook. Now what we have to do, we have to convert this Jupyter notebook as our modular coding implementation. Okay. So guys, now we'll try to convert this notebook as our modular coding. That means here everything will be writing. And see, once you implemented the notebook, you don't need to write the code from scratch. Everything you can copy paste from your notebook only. Let me show you. So I think you remember the first thing we have to update the config.yaml, and this is already updated. I don't need to update. And apart from that, this two file is also updated, because as of now I don't need it, but I have updated some dummy value. Now first thing what I have to update the entity. Now let me open the entity file. So inside src, you can see we are having this entity folder. Inside that we are having the config entity. Let me open it up. And inside config entity, whatever entity you have created, just try to copy paste. So this is my entity. So copy and paste. Then after that, I have to update my configuration manager in src config. So let me now open this config folder. Inside that, configuration.py. Okay. Now whatever configuration you have created, let's try to copy paste. So this is the import, and this is my configuration manager. Okay, that's it. Now I also need to import data ingestion config from my entity. So let me import it. So from ml project dot entity dot config entity import. Okay, import data ingestion config. Now let me see whether any error or not. No, everything is fine. Now we have to update the component. Okay, so let's open the component folder. Inside that, I'll create a file called data ingestion .py, and let's copy the component code. After configuration manager, this is my component. That's it. Again, I have to import the config data ingestion config from entity. So from ml project dot entity dot config entity import this data ingestion config. Now, is there any error? Okay, I also need to import the path library. Okay, so let me import. So from pathlib import path. We should be capital. Now I don't think there is any error. Yeah, everything is fine. Now the next thing, I have to update my I think remember I have to update my pipeline. So let's open the pipeline. So inside pipeline folder, I'm going to create a file called stage 01, because this is going to be first stage data ingestion .py. Okay. Now here, I think remember, if I want to execute the pipeline, I need configuration manager and this component as well. Okay, so let me import all the necessary library inside here. So these are the necessary library I need: configuration manager as well as my component, data ingestion component, and I'm also importing the logger. Now I have to give this stage name first of all. So stage name should be data ingestion. Okay. Then I'll create a class called data ingestion training pipeline, and constructor should be empty. And inside main function, what I've done, I've just copy pasted the entire pipeline. See, this is what actually I've just copy pasted inside that. That's it. Now, if you execute the main file, that means your entire pipeline would be executed. Now, this is going to be my first stage, okay, inside the pipeline. Now, let me test whether everything is working fine or not. So let's call this main function inside my endpoint. So I'll consider main.py as my endpoint as of now. Later on, I'll switch to the app.py. Okay. So first of all, let me import this pipeline, data ingestion training pipeline from stage 01 data ingestion from the pipeline itself. Okay, you can see. Okay, I'm importing it, as well as I'm also importing the logger. Okay. Now the next thing, I will execute this line of code. Okay. That means I'm initializing my training pipeline, and from the object itself, I'm calling the main function. Okay, this main method, whatever main I have defined, this is what actually I'm calling. And I'm calling inside try except block. Okay, let's see if any exception is there. It will show me the exception as well. Now let me delete the artifact folder and let me show you the execution again, whether it's working or not. So I'll open up my terminal. Inside project folder, I will open up my terminal. I'll activate my environment. Now what I will do, I'll execute the main.py. So Python main.py. Okay, so it's not getting executed. Just a minute. Okay, I have to save the file, Ctrl S. Now let's execute. Now see, my pipeline is executing. Now if I show you in the artifact folder, see, it has ingested my data. Okay, so that's how, if you have implemented the notebook, very easily you can convert them to the modular coding. Okay, and this is what actually modular coding. We are managing the different files. Okay, now we'll be following the same approach to implement our remain actually, let's say stage, like let's say data validation, or let's say model trainer, or let's say data transformation. Whatever we are doing, we'll be following the same stage. Got it? So now I'll go a little bit fast because I think you got it, what we have to do exactly. Okay, the entire, let's say, project workflow, like how should we update the folders and file. Okay, now I think you got it. Now the next thing we'll be doing the data validation. Okay, data validation, first of all, we'll be doing the notebook experiment. Then similar wise, we'll also try to convert this notebook as a modular coding. So guys, now let's start with our data validation. So for this, I'm going to create another file inside research called 02 data validation .ip by nb. So let me select my kernel. Now similar wise, I will execute this line of code just to get back to my project working directory. Now see, everything would be common as of now, whatever we have done, only the logic would be different. Okay, that's it. Now you can see that I'm inside my project working directory. Now see, what exactly we're gonna perform inside data validation. That means here we'll be validating the data. Let's say the data actually we're having. So it is having some feature, yes or no. Let's say fixed acidity, volatile acidity, and so on. And based on that, I have to predict the quality of the wine. Okay, I think you know. So here, first of all, I have to check. Let's say the data actually we are using, it is having all the column or not. Okay, all the column or not. If any of the columns is missing, that means this data is not, correct data. So that time what we'll do, we'll not start the training. We'll raise the exception to the user. Your data is not in a correct format. So try to give the correct data. Okay. Otherwise, if it is true, that means all the columns are exist. I will try to proceed with the training, because at the end training would be costly, right? If I'm taking any, let's say, instance to the cloud platform, and there if I'm training my model, okay, so it would be costly. And if my one of the column is missing, that time I won't be getting my desired output. So why will be doing the unnecessary computation there, right? So that's why first of all we have to check the data, whether our data is in correct format or not. If it is correct format, then we'll start with the training. Otherwise, we'll stop the training. Okay, we'll raise the exception. This is the idea. So first of all, let me show you the data. So let me import the pandas library and let me read the data. So you can see data is available inside artifact data ingestion and one quality red CSV. Now if I show you the data, see, this is the data. And if I show you the information, so it is having this many of column, okay, and this is the data type of the column, okay, and this is our target variable, quality of the wine. Now what I have to do, guys, based on that, I have to create one schema file. I think you remember we created one schema.yaml. Now I already created the schema. See, this is the schema. Okay, that means the columns, your all the columns. You can see all the columns here I have defined. Based on that, I have also defined the data type of the column, and I also defined my target column, which is nothing but quality. Now with the help of this YAML file, what we'll do, we'll just try to validate. We'll just try to read our data and we'll check whether all the columns are exist or not. Okay, all the columns are exist or not. If it is exist, status would be true, otherwise status would be false. This is the simple code we'll be implementing. Now let me show you how it can be done. Before that, let me show you the configuration. That means data validation related variable. So this is the data validation variable. That means it will create another folder called data validation. Inside that, it will actually validate the data. That means it will create a status.txt file. Inside status.txt file, it will say whether validation status is true or it's false. If it is true, that means data is correct. If it is false, data is not correct. Okay, this is the idea. And this is my data path. Like where we'll be reading the data, we'll be reading the data from the artifact data ingestion min quality red.csv. Okay, and this folder would be created. That's it. Now with the help of that, let's create the entity. So let me show you how to create the entity. So this is the entity, guys. You can see I'm returning only this variable only. Okay, one by one. And one more extra variable I'm using called all schema. That means this schema file I also need to read, right? And I have to like return all the let's say column as a dictionary. Okay, that's why it's a dictionary type. I'll tell you whenever we'll execute the code, that time you'll get the idea. Now I have to create the configuration manager. So let me create the configuration manager. So I think you remember we have to import these are the library. Then this is going to be my configuration manager. Inside that, I'm reading the YAML file, creating the directory, and this is my data validation configuration. And this is the return type. The return type we have defined. And inside that, you can see I'm returning all the variable, root directory, status file, unzip directory, and all schema. Schema I'm getting from the schema itself. You can see all column schema. Okay, so here we're reading the schema file and we are returning all the column. That means it will give me all the column name. Okay, and this column name I'll get as a dictionary. Okay, I'll get as a dictionary and I'll match. Okay, I'll match with my let's say actual column of my data. This is the idea. Now let me execute. Now I have to create the component. So let's create the component. Let me import these at the library. And this is the simple Python verification code I have written, guys. See, this is nothing complex. Data validation, you can see the class is data validation. Inside that, it will take the data validation configuration and it will validate all the column. That means first of all, status would be none. It will read the CSV file, that means my actual data. It will list down all the column. Okay, then I will get all the keys. Okay, from my configuration. That means this schema, it will be a dictionary. And if I want to get the keys, guys, so it will be the keys. Okay, because this is the value, I think, remember. Okay, I need all the keys. So you can see I'm getting all the keys. Then after that, I'm writing one for loop. Inside that, I'm checking if column is not all schema, validation would be false. Okay, and you have to write this validation in a txt file. Otherwise, it would be true. Okay, and I'm returning the validation status. It's a very simple code, very simple verification code. Now here, one more verification layer you can add. You can also check the data type, whether it's a float or not, whether it's a float or not. Okay, that's how you can also check the like data type. So here I haven't checked the data type because you can see all the like data is in a float format. Okay, float format. That's why I don't need to check the data type. But if you're having multiple data type, you can also add another layer. You can add another for loop. Okay, inside that, and you can also check the data type, whether this column is having this data type or not. Okay, so this second layer verification you can also add. See, whatever Python, let's say logic you have learned, same thing you can apply here. So I'm not teaching you the Python, how to write the Python code, you know that, right? I'm only showing you the strategy, how we can follow. That's it. Now after that, let me execute. And last thing, I have to create the pipeline as well. So let me create the pipeline and let me show you the execution. So this is going to be my pipeline. Configuration manager, getting the data validation config and passing it to my component, and I'm executing this particular function. That means it will validate the data. So if I execute in the artifact, it will create another folder called data validation. Inside that is status.txt. Now you can see status is true. Okay, that means all columns are exist. Now let's say by chance one of the columns is missing. Let's say this columns is missing. Okay, now if I execute the code again, so I have to execute from again here. Now see, it should be false because one column is missing here. Okay, I hope you got it. How this thing will work. Your data validation will work. Okay. Now let me delete this artifact because I'm going to create the component. That means my modular coding there will be executing all of the code. Now let's try to convert this code as our modular coding. Okay, so first of all, what we have to do, we have to, I think, remember these files are already updated. You don't need to update, create the entity. So let me open the config entity. Inside that, I'm going to copy all of the entity I have created. Just try to copy this class and try to mention after that. That's it. Now, configuration manager. So let's me open this configuration.py. And see, this class is already have, okay, this class we already have. So here I already need the method. So let me copy the method, get data validation config. Let's copy. And after data ingestion, I'll try to mention it here. That's it. Now I also need to import this data validation config from the entity. So from here, I can import it. Okay, that's how with the help of bracket, you can import multiple, let's say function, okay, multiple, let's say object from a file itself. Now there is no error. Now next thing, I have to create the component. So let's create the component. I'll go to the component. Inside that, I'm going to create a file called data underscore validation dot py. Let me copy the component. This is my entire component. Now data validation config I have to import. So let's me import. It is available here. I can copy. I only need the data validation config. That's it. Anything else I need? No, I think everything. Okay, I need the pandas as well. So import pandas as PD. Everything is fine. Now let's create the pipeline. I think. Let me show you. Yeah, so pipeline I have to create. So let me go inside pipeline and create another file called stace02 underscore data validation py. And similar wise, we'll be creating the pipeline. So this is my pipeline, guys. You can see I'm importing configuration manager, data validation, my component. This is the stage name data validation. And this is the class. Inside that constructor would be empty. And main function, inside main function, I'm copy pasting this code only. That's it. Okay. So this is going to be my pipeline. Then I also need to call this pipeline inside my endpoint. So endpoint would be main.py. So let me show you. First of all, let me import data validation pipeline from the pipeline itself. You can see. Okay. Now let me call the main function. Data validation, I'm calling the main function, and it is also logging the information like this stage has started and this stage has ended. Okay, if it is execution is successful. So if this execution is successful, it will also log the information. I think previous log also you can see. So you can see data ingestion completed. Okay, after ingesting the data. So this is the log. Now let me show you. So I think I have deleted. Now let me execute. First of all, let me save. Main.py. See, data ingestion is running. After that, data validation is started. Now let me show you artifact, data ingestion, all the data validation status would be true. Okay, that means everything is working fine. Now next stage will be doing the data transformation. Okay, inside data transformation, we'll be doing all kinds of feature engineering. That's a 10 test bit operation you can perform here. Okay, so now let's start with the data transformation part. So again, let me create one notebook file. 03 data transformation, and let me execute the same code here. Now I'm inside my project working directory. First thing, let's update the config.yaml. So this is my data transformation configuration. Okay, so it will create a data transformation folder. Inside that I will keep all of the transformation artifact. Okay, and this is my data. From here I'll be reading the data. Okay, data path. Now let me save and let me create the entity as of now. So this is your entity. I'm returning these two paths only. Then after that I have to create the configuration manager. I think you already know. So this is the configuration manager. Configuration manager reading all the YAML file, and this is the get data transformation configuration, and this is the return type. Okay, I'm returning the root directory as well as the data path. That's it. Now let's create the component. So this is my component. So see, here we'll be only performing the data 10 test split, okay, operation. But here, see, here I already added. You can add different data transformation techniques such as scalar, PCA. You can also perform different kinds of EDA, okay, in the machine learning lifecycle. Okay, so here I'm only adding 10 test split because this is a already clean up data. Okay, so because see, this is the demo I'm showing you. This is the template I'm giving you. Now you can add anything, whatever, let's say, inside machine learning, whatever, let's say, pre-processing, whatever, feature engineering, EDA is required, everything you can perform here. You just need to create different functions for this. That's it. Okay, see here what I'm doing, I'm only taking the data and performing the 10 test split operation. Then I'm saving as a CSV file, okay, inside my data transformation. That's it. Now let me execute, and after that let me create the pipeline. So this is my pipeline. Okay, so this will execute my 10 test split. Now if I show you, see, 10 data transformation is created. Inside that, training CSV as well as the testing CSV is available. Okay, so yes, this is the transformation. Now let's try to convert this code as our modular coding. So to convert this thing as our modular coding, so first of all, I think remember we have to update the entity. So let's update the entity. So here is my entity. Let me copy and let me update it here. Then after that I have to update by config.py. I'll copy this method and let me update it here. I also need to import this data transformation config from the entity. I think it's missing. No. Now what I have to do, I have to write the component. So let me open the component. So data transformation .py. So let me copy. That's it. So let me import this as well. So from mlproject.entity.config entity import data transformation config. I need anything else? No, fine. Now let me create the pipeline. So let's go inside pipeline. I'll create a file called stage03 data transformation. But see, whenever I'm executing data transformation, there you have to write one small logic. See, what is the logic? First of all, you can see I have imported all the library, and this is the class I prepared, and this is my main code. Okay, see what you have to do. First of all, you have to open that status.txt file, which is available inside my validation. I think you remember. So inside validation, this is the status.txt. And whenever status is true, that means my data is in correct format. That means there is no issue with my data. That means I can start with the next stage, right? My data transformation model trainer and all. So that is what actually I'm doing. I'm extracting the status and I'm checking if status is true, then I'll be running the pipeline. Okay. Otherwise, I'll raise the exception to the user. Your data schema is not valid. Okay. So this is one small layer of verification you have to do. Okay. Before executing the next pipeline. Got it? So yes. So this is what we have to do. Now let's call this thing in our endpoint. So this is my endpoint. So let me import transformation pipeline and let me call the function. Data transformation, I'm calling the main function from the data transformation training pipeline. Now let me check whether everything is working or not. I'll remove the artifact. Now let me execute the program. See, execution is complete. Now let me check. See, data ingestion done, validation done, and transformation done. And this is my test CSV and trend CSV. Okay. Yes. Now the next stage will be doing the model trainer part. Okay, so guys, now let's start with our model trainer. So first of all, let me create a one Jupyter notebook. I'm going to name it as 04 model trainer. Let me select the kernel. Now I'm going to execute the similar code. So you can see I'm inside my project working directory. So first of all, I have to update my config.yaml. So let me update it. So this is my model trainer configuration. So you can see it is going to create a folder called model trainer. Inside that, it will save the model. Okay, model.joblib. You can also save the model in a pickle format. It's up to you. And this is my training data path and this is my testing data path. Okay, I hope it is clear. Now, one thing you have to also mention the parameters of the model. So here I'm going to use this ElasticNet model. And I think I already showed you ElasticNet model is having actually two parameters. Let me show you. So if I search for ElasticNet sklearn. So if you go to the sklearn documentation, you will see that it is having actually so many parameters, but we'll be tweaking these two parameters actually. Alpha and L1 ratio, because this is the regularization parameter. I think you already know. Let's say in future you want to change, these are the parameters. Okay, just to get a good performance from the model. So what you need to do, you don't need to open the, let's say, your component. That means you don't need to open the actual code. So only you will be opening this params.yaml file and there you will be changing. And it will reflect inside all of your code. Okay, so this is the idea. So let me show you. So here you can define the parameter like that. It's not about actually ElasticNet. You can use any kinds of model. You can use random forest, you can use decision trees, but make sure whatever parameter actually we are having with respect to that model, just try to mention in the params.yaml file and from there you can read it. Okay, that's it. Now here I have defined the ElasticNet, alpha and L1 ratio. Going forward, I will also show you how we can perform the hyperparameter tuning as well. We'll be keeping different model, okay, model configuration, and we'll be loading all of the model one by one, and we'll be doing the hyperparameter tuning, and based on that we'll be selecting the best model. But as I already told you, this is the simple implementation. Okay, for the first time we are implementing because there would be lots of people they are not familiar with these are the concept. That's why I'm starting with very basics concept at the very first. Okay, so that it will give you some understanding like how we can write the modular coding, how we can create the pipeline, so that this concept you can use whenever you will be whenever you will be creating any kinds of advanced kinds of, let's say, project. Okay, that is my main intention. So this is my params.yaml I have prepared. Now let me get back to my Jupyter notebook, and here I'll be creating the entity right now. So this is my entity. So you can see I'm actually initializing all the variable. Apart from that, I'm also initializing alpha and L1 ratio and target column. Okay, these are the three variable. Now let me define. Now I'll be creating the configuration manager. So configuration manager will return all the variable one by one. You can see I'm reading this YAML file. After that, this is my method. Okay, get model trainer configuration, and it is returning everything. Okay, one by one. And target column where you will get from the schema. Okay, schema, I think YAML file, and you already know. And params, actually I'm extracting from the params. Okay, params one. So that is why actually we keep this YAML file so that we can do the configuration management. I hope it is clear. Now let me execute. Now I'll be creating my component, model trainer component. So let me import some of the library. So here you can see I'm importing ElasticNet from the sklearn because we'll be using this model. And this is going to be my final training code. See, I have created one class called model trainer. So it will take the model trainer configuration, and this will train the model. It will load the data first of all. Then after loading it, actually, I'm extracting the X-train and Y-train. Then after that, I'm feeding to the ElasticNet model. And all the configuration I'm reading from my configuration file. Okay. Then whatever model actually I'm getting, I'm doing the just dump operation. That means it will save that model, okay, inside my model trainer folder. Now let me show you. And if I want to execute, I need a pipeline. So this is my pipeline, guys. I'm initializing my configuration manager, getting the configuration, passing it to my model trainer, and I'm calling the train method. Okay. Now if I execute, you will see that model will be trained. Now it's executed. Now if I go to the artifact, model trainer, see model.joblib is present. That means you have successfully trained your model. Now let's try to convert this code as our modular coding. Okay, so to convert into the modular coding, first of all, let me define the configuration. So entity, sorry, I have to define the entity. So let me open the entity. I'll copy the entity from here. This is my entity. Then after that, I also need to prepare my configuration manager. Let me copy this method. And I'll open up my configuration.py, and after data transformation, I'll add it. Now I also need to import this model trainer config. Then the next thing, I have to update the component. So let me create a file here inside component, model underscore trainer. Let me paste the code. So anything else? Okay, I need this one. So from ml project dot entity dot config entity import this one. Nothing else I need. I think everything is there. Okay, fine. Now let me create the pipeline. So I'll go to the pipeline section. So here I'm going to create a file called stage 04 underscore model underscore trainer dot file. And this is going to be my pipeline. Okay, I'm initializing my configuration manager, model trainer, and this is my final pipeline. Okay, inside this class, you can see the same pipeline I'm executing. Got it? Now let me call inside my endpoint. So main.py. First of all, I have to import this from the pipeline. So you can see I'm importing this model trainer training pipeline from my pipeline. Then after that, I will initialize it. Model trainer stage. So you can see this is my model trainer stage. I'm calling the main.py. Okay. So here I'm calling this main method. Now let me show you whether it's working or not. I can remove the artifact. Now let me open up my terminal and Python main.py. See data ingestion, validation, after the transformation, and model trainer completed. Now if I show you, see all the stages run successfully. There is no error. Okay. So now the next stage we'll be doing called model evaluation, and this is going to be our last stage here. Okay, so now let's start with our model evaluation. So let me create another file inside resource folder. I'm going to name it as 05 model evaluation. Okay, so select the kernel and let's execute the same code. So the first thing, let's update the config.yaml. So this is my model evaluation config. Okay, it will create a folder called model evaluation, and inside that it will save the metrics. Okay, you can see the metrics actually will be getting the accuracy score. Okay, will be saving inside this metrics of this song. And apart from that, this is my test directory because I need the testing data to perform the evaluation. And this is my model path. Okay, like the current model we have trained. Now let me create the entity. So this is my entity. You can see I'm initializing all the variable as well as the target column. Then let's create the configuration manager. So this is my entire configuration manager. You can see only this part will change. Okay, it will return these are the variable. After that, I will create my component. So here I'll be calculating actually mean squared error, mean absolute error, and R2 score, because this is a regression problem statement. Okay, so you can see this is the code. So here I've created a function separately called evaluation matrices. It will take the actual value as well as the predicted value. Based on that, it will calculate RMSC, ME, and R2, and it will return. And you can see it will save the result inside this method. So it will load the test data, load the model. After that, actually it will do the prediction and it will pass inside this method, that means evaluation matrix method, and it will return you this score, and this score actually will be saving as a JSON. And how to save as a JSON? Because I think you remembered inside utility we created one method called save JSON. I think you remembered. So this is what actually we have imported. I think you can see here. So save JSON. Okay, we have imported from the utility itself. So now let me execute. Now let's run the pipeline also. So see, it has done. Now if I open the model evaluation, this is the metric, guys, I got. Okay, so this is the RMSC, ME, and this is the R2 score. And again, I'm telling you guys here, I'm not trying to gain the good accuracy. Okay, I'm creating the pipeline. Later on, we'll be learning how we can perform the different kinds of feature engineering, different kinds of EDA. Based on that, we can get a good model. Okay, great. Now I think this is done. Now let's try to convert this notebook as our modular coding. Okay, so for this, what I will do, I will first of all copy the entity inside my config entity. So let me open. So I'll copy the entity. Now I'll also copy the configuration manager. Let me import this as well. Then I will create the component. So inside component, I'll create a file called model evaluation. So I need to import this save JSON and path as well as this model evaluation config. So let me import. So from ml project.utils.common import this save JSON. Then I need from ml project.entity.config entity. Okay, import this model evaluation config. Then I also need the path. So from pathlib import path. Okay, now I think it is done. I don't think anything else. Yeah, fine. Now let me create the pipeline. Okay, so for pipeline, I will open this folder. Now let me create a file called stage05 model evaluation. And this is my pipeline. Okay, so now let me call this pipeline inside my endpoint. So I'll open up my main.py. First of all, let me import. You can see I've imported this model evaluation training pipeline. Then I'll call the stage here. Okay, that's it. So now let's try to check whether it's working or not. Let me delete the artifact. Now I'll open it, execute main.py. Okay, execution done. Now if I show you my artifact, see model trainer, model evaluation, and metrics is done. Okay, that means everything is there. So we have successfully completed all the stages. Now we'll be creating the prediction pipeline. That means everything will be integrating inside app.py. We'll be creating one user interface there, web application, so that user can perform the prediction from that. Okay, we'll be creating a simple web application here, and then after that we'll be deploying this project, okay, to the cloud platform. But before that, we'll be also performing the Dockerization, okay, because I told you for the CICD deployment we need the Docker file. Okay, so now let's create the prediction pipeline. Okay, so for prediction pipeline, we'll be creating one file inside pipeline called prediction.py. Okay, and inside that I'm going to define a class called prediction pipeline. So here what I'm doing, you can see I'm loading the model, okay, loading the trained model. The model actually we have trained from the artifact model trainer. And after that, what I'm doing, I'm creating a method, and whatever data actually user is giving, I'm doing the prediction, and this prediction actually I'm returning. That's it. So this is the simple prediction pipeline, because inside prediction pipeline you don't need so many things, because here it's a simple implementation. Going forward, whenever let's say we'll be implementing advanced kinds of project, there will also show you how we can perform that test data transformation as well, because we also need to perform some transformation technique. Okay, so we'll be creating the sklearn pipeline for this. So I think you know what is sklearn pipeline. So this is a simple one. That's why we created the simple prediction pipeline as of now. Got it? Now next, what we'll be doing, we'll be creating the user app. That means we'll be designing that HTML and CSS code. With that, actually we'll be creating one user application, and there actually user can do the prediction. Okay, after that we'll be deploying this project. And no need to worry if you're not familiar with HTML and CSS. You can get these kinds of, let's say, template from any kinds of website nowadays. And this is not your task. This will be done by front-end developer, okay, in your company. So no need to worry about that. I'll share my template with you so you can use them as it is. Okay, so now let's create the app.py. Okay, so now let's create the app.py. So I'll open the app.py, and inside that actually we'll be using Flask to create the web application. So here you can see, guys, I'm importing Flask render template and request. Okay, so if you know basics about Flask, I think that would be better. And we are also importing NumPy and pandas. Then I also need to import my prediction pipeline from my pipeline itself. Okay, then if I want to initialize the Flask, I have to write this code. If you go to the Flask documentation, you will see that they are also initializing this particular line. Then we'll be creating 3 routes. One is for the default route. That means whenever user will hit my application, they will get the index.html page. Okay, and it will render the HTML page. And you can see inside template we are having the HTML. Okay, HTML actually file, but inside that I don't have any code. So I'll show you the code. Okay, I already prepared one HTML and CSS template for you. You can use it as it is. Then apart from that, I also need another folder called static. Okay, inside static we'll be keeping all the, let's say, rendering image, then JavaScript, CSS. Okay, these are the code as well. So let me quickly add these are the things in my project. So guys, as you can see, I have already added the index.html. So this is the HTML code, and no need to worry if you're not familiar with HTML. I will suggest no need to worry. This is not your task. It will be done by the front-end developer. Okay, so this is one actually basics form actually I'm creating. So this is the entire HTML, and this is another HTML I'm creating called results.html, because see, this one I need whenever user will hit the submit button, they will get one result page. Okay, so this is the result page actually I prepared. And apart from that, there is another folder called static. Inside that I have kept some asset like image, then icon. So these are the thing, and this is the CSS code, and this is the JavaScript code. No need to worry. So this one I have downloaded from the internet. So let me show you. So there is one amazing website you can refer called Bootstrap. So Bootstrap will give you all kinds of actually HTML and CSS kinds of template. Okay, so you can see if you can go to the example section, you will have all kinds of form. Okay, so you can choose any of them, you can download as it is. Apart from that, there are so many form. You can just simply search like HTML form template download free. You will get different website. You can also download it, and based on that you can do the customization. Okay, so I'll share my template with you so you can use it in your every project. If you're getting this kinds of machine learning project, you can use it as it is. Okay, and the change you can do the title. Then if you want to change the form and all, you can change it here also. Let's say this is the form. Now I'm taking all the, let's say, input: fixed acidity, volatile acidity, citric acid, residual sugar. Okay, these are the form you can change here. Okay, you can change the name. Got it? So if you have at least basics knowledge about HTML, like how we can at least change the variable, so you will be able to use the HTML code. That's it. Now let me close it, and I will render. I will show you, okay, how it will look like. So so first of all, I will create a training route here. So whenever, let's say, user will give the /train, okay, so it will start the training. And for training, actually what I'm doing, I'm using voice.system command. Inside that, you can see I'm executing python main.py. Python main.py is a command, I think you know. And if you want to execute any command inside Python, you can use voice.system. Okay. Then once training is done, it will give you training successful. So then we'll be doing the prediction as well. So this is the prediction route I have created. Okay, entire prediction route. So here I'm taking all the input from the form. Okay, you can see request.form, like fixed acidity, volatile acidity. Okay, so you can see here inside index.html. So here is the input I'm taking. So fixed acidity. So this is a form, actually. You can see form. Okay, this is a form. So from here, actually, I'm taking the input from the user. And once I have all the data, what I'm doing, I'm creating one list. You can see with all the features. Then after that, I'm reshaping it. Then I'm doing the prediction. And whatever prediction actually I'm getting, I'm rendering in my result.html. That's it. And if some exception is going on, it will throw the exception. Otherwise, it will render the index.html page. And now if I want to show you my application, so you have to execute this command. So here I'm running. So here I'm running my application localhost port number 8080. And here you can also mention debug is equal to true. Okay, that means if you change anything, it will automatically reflect in your code. This line I don't need. Okay. Now let me execute and let me show you the app, how it will look like. So let me clear. Make sure, first of all, you train the model. Okay, model should be present inside the artifact. Otherwise, you won't be able to do the prediction. So for me, I already have the model. So I'll just write python app.py. Now give the allow permission. Now see your application is running. Open the Google Chrome and search for localhost port number 8080. See, this is the application. Okay, this is the web app I have created. It's a simple web app. Find quality prediction, a quality checking web app. You can change the title also from the HTML page. Now here you can pass the value. Let's say I will give any value you can give. As of now, let's give some dummy value. Okay. You can check the data and you can give the value. Okay, with respect to that. Just for quick purpose, I'm giving some dummy value here. Now let me do the prediction. Now see, it is telling this is the wine quality. Okay, that means it is working fine. You can also add your social media link. So these are my social media link, my LinkedIn, my YouTube, as well as my GitHub. Okay, so yes, I hope guys you got it, how we can create the web application. If I'm creating any kinds of let's say machine learning project, it's not like that always you have to like keep this code as a raw code. You just also need to create these kinds of web applications so that if anyone is coming, those who are not familiar with coding, they can also at least use your application. Okay, I hope it is clear. So now what we'll be doing the deployment of this project. So we'll be creating the Docker file first of all. Then I'll show you the CICD deployment on the AWS cloud. Now let me commit the changes in my GitHub. So before committing, I also need to add the artifact inside my .gitignore because I don't want to push my artifact. Okay, so artifacts. So this folder I'm not going to push. Now let me commit the changes. App added. Okay, done. Now if I go to my GitHub and refresh the page, you'll see that everything is up to date right now. Okay, now let's create a Docker file and let's do the deployment. Okay, so to create a Docker file, just try to first of all create a file here. So I'll name it as Docker file. So make sure you are giving the similar name, otherwise it won't be working. D should be capital. And I'll get the Docker icon here. Okay, once you have created this file, and there won't be any kinds of extension. Now inside that you have to mention the Docker command. So these are the command you have to mention. So first of all, here I'm taking one Python image actually, because I think you remember we are using Python 3.8 right environment. So that's why I'm taking one Python 3.8 Slim Buster image. If you have basics knowledge about Docker, it would be better. Otherwise, I know that you will be getting confused, but as of now, just try to remember. This is the Docker command actually I need if I want to Dockerize the entire source code. Okay, that means it will Dockerize the entire source code and this Docker image actually will be using for the deployment. Okay, this is the idea. Now I'm creating a directory called app. Inside that I'm copying all of my source code and I'm doing the requirement installation, and then I'm executing my app.py. Okay, that's it. And it would be running inside Linux environment. That's why you have to give the Python 3 command. Okay, so this is the simple Docker file. Now let's start the deployment. For this, definitely you should have a AWS account. If you don't have the account, just try to create one account. Okay guys, so now we'll start the deployment, and here you can see I have already added the deployment steps, like what are the things we're gonna perform. You can see first of all I have to log into the AWS console, create the IAM user. Okay, then this is the deployment actually description. Like first of all we'll be building the Docker image of our entire source code, then we'll be pushing this image to the ECR. So here we'll be using some services from the AWS. One services we'll be using called ECR, that means Elastic Container Registry. So here you can push any kinds of Docker image. So this is the alternative of the Docker Hub. I think you know Docker Hub. Okay, there you can also store the Docker image. Then we'll be launching the EC2 machine. EC2 is a virtual machine, virtual computer. Then we'll be pulling this ECR image to the EC2 machine. Then we'll be running that image to the EC2 machine. Okay, then we'll be doing some port mapping. Then we'll be able to access the application. And this is the policy I have to give. Okay, whenever we'll be creating the IAM user. So you can see all these steps actually I have written down here. So we'll be following these are the step one by one. See guys, before starting the deployment, you need one very important you can say file called CICD.yaml, and this file you have to create inside a folder. So let me create the folder first of all. So the folder name should be .github. Okay, .github. Inside this folder you have to create another folder called workflows. Okay, now inside workflows you will be creating one file called CICD.yaml. So this YAML file will help us to do the deployment. Okay, it will execute all the automated command, because here we'll be using GitHub action, okay, as our CI/CD tool. And for this we need this file actually, and the folder structure should be like that. First of all, .github, inside that workflows, inside that CICD.yaml, and these are the command you have to mention here. And now you can ask me where I got this command. Just simply search on internet how to do the CI/CD deployment with GitHub action AWS. You will get this CICD.yaml file, okay, from the GitHub site, and you can copy paste the same thing and you can do some modifications. So what I did some modification here, and rest of the things I keep it same. So it will perform the continuous integration, then continuous delivery, as well as the continuous deployment. Okay, I'll tell you what will happen whenever we'll be doing the deployment. As of now, just try to remember this is the thing. This is the thing you have to do. Now you have to mention the port here. I think you remember we are running our application in port number 8080. That's why we have given port number 8080. If you are using any other port, you have to change the port number here. Okay. Yes. Now, see, before starting the deployment, guys, first of all, I will tell you what is CI/CD deployment exactly. For this, I already recorded one video previously. I'll add this video part in this video. This will give you the entire understanding what is CI/CD deployment and why we need it exactly. Okay. Then after that, we'll be starting the deployment. So guys, as I already told you, here we'll be doing something called CI/CD deployment, right? And I already told you what is CI/CD full form. It's continuous integration, continuous delivery, or deployment, right? So inside continuous integration, continuous delivery, what happens? Let's say you are the developer. Okay, let's say you are the developer. So what is your task? Your task is to develop a project in the development, let's say, environment. So development environment means like your local system. Let's say you are using your laptop or computer. Let's say local computer. Okay, local computer. Fine. Then what we are doing, I think you remember, we are committing this code to the GitHub, right? We are doing the code management. I think you remember. That means whenever I was adding some new feature, I was pushing this code to the GitHub. Yes or no? Okay, with the help of Git client, we are pushing the code in the GitHub server. Now what happens actually, let's say after deployment. So this is called actually development server, or I can write this is actually development environment. Okay, development environment. So after implementing this project, what we have to do, we have to deploy this project, yes or no? Let's say somehow you have deployed this project on the AWS cloud. Let's say this is your AWS cloud. Fine. So let's say you have deployed this project to the AWS cloud. Manually you just created a, let's say, instance there. You just took a machine there, a EC2 machine, and you manually deployed this project. Now it will give you some endpoint. Okay, endpoint. So with the help of this endpoint, any of the user, okay, user can access your application. Now let's say after 4 months or let's say 6 months, you want to add some more features in this, let's say, application. Let's say you are deploying medical chatbot. The medical chatbot we implemented, I think you remember, right? Let's say you want to add some more data, you want to add some more knowledge base, and you want to add some more features in this application. Then what you have to do, you have to again develop this, let's say, features in your code. Then what you will be doing, again, you will be deploying this application to the AWS cloud. Now just try to see, whenever you are deploying the project for the second time, let's say this is the first time you have deployed, then you are trying to deploy for the second time, then what you have to do, first of all, you have to stop this application in the AWS. Okay, stop this application, then you will be uploading your updated code. Then this code will reflect to the endpoint, then user will able to access that. Now let's say in between, whenever you stop this AWS server, let's say your application, let's say it took 3 hours. It took 3 hours to change the entire source code. That means change the entire features, okay, of your application. So what will happen? 3 hours user won't be able to access your application. So they will come your website and they will see server error. Okay, server error actually they will get. So if user is getting this kinds of experience, so definitely it would be a negative, let's say, effect, okay, on your application. So next time actually they are not going to use your application, yes or no? Let's say if ChatGPT is down for the let's say 3 hours, definitely people will move to the Google Bard or any other, let's say, software, whatever actually we are having. Okay, so now see, ChatGPT is also updating their, let's say, application day by day. But did you ever observe this server is down? No, you are not seeing this server is down, but still they're able to make the changes in their application. How? Because they are following something called CICD approach, continuous integration, continuous delivery. That means this application is keep on running, but in the backend they're pushing their source code, they're pushing their, let's say, new features, and this feature is automatically getting updated. Okay, so this is called actually CICD. That means you are not going to deploy this application manually. Instead of that, what you have to do, you have to follow the CICD. That means what will happen? Let's say you have changed something in your code, you will push the code to the GitHub. Okay, GitHub will automatically let's say deploy your code to the AWS cloud. It will automatically push your code to the AWS cloud, and your endpoint would be automatically updated. Okay, automatically updated, so that if user is using your application, okay, they won't be feeling any kinds of, let's say, server down issue. Okay, server down issue actually they won't be feeling. Got it? So this is what actually we have to do. That means we'll be creating the entire pipeline, entire, let's say, CI/CD pipeline. So we'll be just pushing the code in our GitHub, and GitHub will automatically trigger this action, and my code will update it to the AWS cloud, and AWS will update the endpoint. Okay, now see, the automated process we'll be doing now. Whenever we'll let's say push our code to the GitHub, GitHub will automatically trigger. How it will trigger? For this you have to use some CI/CD tool. Okay, CI/CD tool, CI/CD automation tool. So here there are different kinds of CI/CD tool. So the first tool you can use something called GitHub Action. Okay, GitHub Action you can use. Then you can use something called Jenkins. Okay, Jenkins. Then you can use something called Circle CI. Circle CI. So these actually 3 famous tools actually we are having in the market right now. So people are using more this GitHub Action, because GitHub Action you don't need to set up anything. It is already set up everything in the GitHub. But if you're using Jenkins and Circle CI, you have to set up this server manually. Okay, so here we'll be using GitHub Action because it is already inbuilt with the GitHub. We don't need to set up anything. Going forward, I will also show you how we can let's say use Jenkins, Circle CI. These are the services as well. Fine. So yes guys, this is the complete high level architecture of our deployment. So guys, I think you saw what is CI/CD deployment and why it is required. And now let's start the deployment. But before that, let me give you some high level walkthrough of this file. See, inside continuous integration, I'm not doing anything. I'm just only doing the echo operation. But going forward, if you are running any test cases, you can execute the test cases inside continuous integration. Inside continuous delivery, I'm just authenticating with my AWS account with the help of AWS access key and secret key. I'll tell you how we get it. And after that, what I'm doing, I'm building my Docker image. Okay, with the help of Docker file. It will build the entire Docker image, then it will push this Docker image to the ECR repository. Okay, then inside continuous deployment, I'm again you can say authenticating with my AWS account with the help of this credential. Then I'm pulling my Docker image inside my EC2 machine. Okay, then I'm executing here. Okay, and then after that we'll be doing some port mapping and we can access our application. This is the high level walkthrough. Now let's go back to my AWS. So I already have one AWS account, guys. If you have account, please try to log in with your account. And if you don't have account, try to create one account. So the first thing what you have to do, you have to create one IAM user here. So let me create one IAM user. So you can simply search for IAM. That means Identity Access Management. That means you are not going to give all the permission of your AWS account. Okay, because you need some certain services here. So we'll be only giving that particular permission. Okay, that's it. I'll just click on the user and let's create a user here. Now I'll give the user, let's say, ML project. You can give any name, it's up to you. Now let's attach the policy. So here I already added the policy, what policy actually you need in the readme file. So here I need two policy. One is the EC2 container registry full access, that means ECR. And this is the EC2 machine. Okay, so simply starts here and just try to tick mark it. Okay, once it is done, just try to remove and again give the second permission. So starts here and try to give the permission and simply click on the next. I'll see that two permission I have added. Now I'll create the user. Now so user is created. Now click on the user, go to the security credential, go to the access keys, select command line, and I understand the above recommendation, click on the next. After that, create the user. And this is your access key and secret key, guys. Okay, now you can download it as a CSV file as well, so that I need later on. Okay, so yes, and don't share this key with anyone, otherwise they will be also able to access your account. Okay, so I'll remove it after the recording, that's why I'm showing you. So it is created. Now you can see this first step we have done. That means we have logged into the AWS credential. That means we have logged in our AWS account. Then after that we created the IAM user, okay, with the permission we have given. Now the next thing I have to create the ECR repository. Okay, so to create the ECR repository, search for ECR, Elastic Container Registry, ECR. So this one. And make sure you track your region. Okay, see, I'm working in the Mumbai region. If you're using any other region, you have to give the region ID. Okay, so here I'll be using AP South 1. Got it? So create the repository. So you can give any name. Let's say I'll give ML project. Keep it everything default, no need to change anything. Create the user simply. Okay, and copy this URI and save it somewhere because I need it later on. So let's say I will save it here as of now. Okay, now the next thing I have to create a EC2 machine. Okay, Ubuntu machine I have to create. So for this, here you can search EC2. That means virtual machine, EC2 instance. So simply just click on launch instance, give the name, let's say ML machine. You can give anything, it's up to you. Select the Ubuntu. Then after that, you can select the instance type. Let's at least take 8 GB memory, guys. Okay, 8 GB memory you have to take. So let's take T2 large, and after that select the key value here. If you don't have a key value, you can also create. Let's create ML project. So this key value here you need. Let's say if you want to access your machine with the help of any third party, let's say a tool, let's say Mobile Extreme or Putty, that time actually you need it. But here I'm not going to use third party tool. I'm going to directly launch the like AWS CLI. Okay, from there actually we can access our machine. I'll tell you how to do it. Then after that, select these two options, HTTP and HTTP, and select the configuration storage. At least take 30 GB. After that, let's launch the instance. So click on the view instance. Now it should be running. Just refresh here. The status should be running. Now guys, you can see my status is running. That means my machine is running. Now click on the machine ID and click on the connect button and simply connect. Okay, it will open a new window and there you will get one black terminal. And this is your production server. So guys, you can see I got the terminal. Let me zoom a little bit. Now let me clear. Okay, now here you have to set up some of the tools. So here I have already mentioned the command. So these are the command you have to execute. First of all, let's update the machine. Okay, then I also need to update the apt-get update. Give the yes permission. Okay, it's completed. Now I'll copy this command. Now we'll be installing Docker, okay, in my machine because Docker is not there by default. So for this, you have to execute this at the command. Okay, so next command. Now I think the last command we have to execute. So these are the Linux command. Now it's done. Now if you want to test whether Docker is running or not, just write docker ---- version. So it will show you the version. Okay, if showing the version, that means Docker is running successfully. Okay. Now the next thing will be configuring this EC2 as our self-hosted runner. That means we'll be connecting our GitHub with our AWS. Okay, that means whatever, let's say, commit will be doing in my GitHub, okay, it will automatically let's say push to my AWS cloud. Okay, for this, what I will do, I will open up my GitHub repo. Make sure you are using your repository, not my repository. Click on the settings. Now here you will see one option called action. Now runner. Now here you will see self-hosted runner. Just try to click here. Select the Linux machine and you have to execute these are the command. Okay, till configure. So let's copy one by one and let me execute here. Okay, so this is the command. Now I'll go to the configure and copy this command and let me execute. Now I'll see that it will connect with my GitHub. Okay, with the help of GitHub action. Now see authenticating GitHub. Now it is asking for the name of the runner group. I won't be giving anything, just press enter. That is asking enter the name of the runner. You have to give self -hosted. Okay, make sure you're giving the same name, otherwise it won't be working. Now it is asking for the label. I'll skip it, press enter. Then again I'll press enter. Okay, now press enter. Now see, it is done. Now let's connect the GitHub. So for this, let's copy the last command and let me execute. Now see guys, connected to GitHub and listening for the jobs. That means connection is done. Now if I check the connection, just go to the runners. You'll see that it's ideal. That means my GitHub is connected. Okay, it's up and running with my AWS. Now whatever change I'll be doing, it will automatically get updated. Okay, but before that I also need some security credential. Okay, with the help of credential it will authenticate with my account. So here I already mentioned, after that you have to add some security. Okay, secrets. So let's add the secret. For this, left hand side you will see secret and variable. Go to the action and repository secret. Okay, create a new repository secret. First of all, give the all the list I have given. So copy this one, AWS access key ID, give the key name, and here you have to give the secret. And where you will get the secret, I think remember we downloaded one, this access key. Okay, whenever we created the IAM user. So let me open it up. So this is my secret. Okay, AWS access key ID. I'll copy. Make sure you're copying before the comma, because it's a comma separated, right? So this is my access key ID, and after comma this is my secret access key ID. So I'll copy and mention it here. So don't do any mistake, otherwise it won't be working. Okay, try to follow the exact step I'm doing. Now create a new repository secret again. Now I have to add the AWS secret key ID. I'll copy and I'll paste it here. And this is my AWS secret access key ID. Before the comma, let me mention. Now new repository secret. Next one, AWS region. So here I was working in the Mumbai. You can see I'm Mumbai, and Mumbai ID is AP South 1. So let's give the name. It should be AP-South-1. Okay, make sure you are giving the same name. And if you're using any other region, you can give the same ID here. So it's done. Now let's give the ECR login URI. Copy. Now what is ECR login URI? I think remember we copied one URI, right? This one. So copy till .com and try to paste it here. And make sure you are giving your one, guys. Okay, not my one. Otherwise, it won't be working. Now the next one I'll be creating ECR repository name. And what is ECR repository name? So here you will get it. So the last one after the /ML project. Done. I think nothing is there. Now let's start the deployment. Okay, so I'll go back to my repo. Now simply I just need to commit my code. So let's commit CICD edit. Okay, done. Now if I go back to my GitHub and refresh here, you'll see that your action would be running. Okay, there is a yellow mark. Now go to the action and see CICD is added. It's running. Now see continuous integration is running. Continuous integration is already done because here I was doing the echo operation. Now continuous delivery is running. Now let me open it up. See, first of all, it will install all the required packages. Then it will authenticate with my AWS. Okay. Then after that, it will build a Docker image and it will push the image to the my ECR repository. So this process will take some time. Let's wait. Once it is complete, I'll come back. So guys, as you can see, my delivery is completed. Now, if you go to the ECR, you'll see the image actually it has pushed. So let me show you. If I go to the Elastic Container Registry, see, this is my ECR has been created. Now inside that, this image has been updated. Okay. Now the next stage is running continuous deployment. So what will happen now? It will again authenticate with my AWS cloud. It will pull the image from my ECR and it will run in my EC2 machine. Okay. So guys, as you can see, my continuous deployment is also completed. Now what I will do, I will get back and here you will see one public IP address. Just try to copy and just paste here and see if I execute. See, it won't be working because I have to set my port. Okay, because my application running port number 8080. Okay, so how to set this port? For this, just go to the security and here we'll get one option called security groups. Then click on this edit endbound rules, select this custom TCP. I have to add the rules, then I have to select the custom TCP and port number 8080, give the 000 and save the rules. Okay, once it is done, get back to the instance. Now copy the public IP address again and try to paste here and give the port number 8080. Okay, now it should work. See guys, my application is running. Now what you have to do guys, first of all, you have to train the model. I think you know. So to train the model, give the /train. Guys, you can see training is successful. Now I'll go back. Now I can do the prediction. Let's give the number. You can give any number. I'm giving, so you can give the actual number. I'm giving the dummy value just to test whether it's working or not. Okay, after that, I'll click on the predict. Okay, I have to give this number as well. You can see this is the quality of the wine. Okay, that means everything is working fine. Now let me show you how we can destroy all these instance you have created. Let me show you the termination. Otherwise, it will charge you. Okay, if you keep on running this. So for this, first of all, I will stop the instance. Select the instance. Click on the instance type, instance, and click on the terminate. Okay, terminate means it will delete after some time. So it is shutting down. After some times, it would be deleted. Now, similar wise, I also need to delete my ECR repository. And delete. And one thing, let me tell you, see, whenever your application is running and if you're adding some new feature, okay, next time, so you have to execute this, you have to uncomment this 3 line. Okay, this 3 line, what it will do, it will first of all stop the current running container. Okay, then it will, let's say, launch your new container. Okay, so make sure whenever you are pushing second time, that means the second time if you're pushing, you don't need to do the configuration. It's just a one-time setup. Okay, so it will automatically update your application in the AWS clouds. But before that, you have to activate this 3 line. Okay, I hope it is clear. Now let me show you how to delete. Yeah, so it is already deleted. Now I will be also deleting the IAM user ML project. Just try to delete it. Give the name. I'll copy and here let me paste. Okay, see, everything is deleted. Yeah, so guys, yes, that's how actually, so yes guys, that's how actually we can do the CICD deployment. See, next machine learning project implementation, we'll be learning some advanced topic. So there actually I'll show you how we can use different kinds of MLOps tool as well. So yes guys, this is all from my side. I hope you liked it. If you liked it, so